necessary to say about selected platform or environment in the study is Google Earth Engine. In fact, all of things such as downloading raster data, preprocessing, processing and analyzing, and also visualizing, all of these are done in this platform. As seen in figure 1, after introducing 3 essential parameters such as raster data, boundary, interested boundary, and interested period time, it's turned to the preprocessing stage. It's containing 3 steps. First, local pastime filtering. 2, cloud pixel masking, and 3rd, convert unit. After this, it's turned to processing stage. First, due to exist 2 images on some days, we calculate a daily image. After that, we extracted 2 mean images from first wave lockdown period time in 2020 and 2019. Let's go. Next session is about result and discussion. As a result, you can see the 2 extracted images over Martian. It's evident that the tropospheric nitrogen dioxide vertical column density over Martian has had a significant reduction in 2020. Especially in the southeastern part as a city center, and a small part of the south. In addition to these, we took out statistical parameters such as minimum, maximum, median, mean, first quartile, and third quartile. As seen in table 1, we also indicated the change rate by 35% in 2020 lockdown period time compared to the same days in 2019. After that, you can see in figure 3 that it clearly shows the whisker box plot that the height of the boxes indicate the reduction in 2020 rather than in 2019. The important things to mention is that the median value and the first quartile and third quartile values are close to the minimum, and it indicated the higher value of nitrogen dioxide vertical column density on some geographical areas. The conclusion brings me to the end of my presentation. We looked at data use methodology result and discussion section. Tropomine-based nitrogen dioxide vertical column density over Martian during first wave lockdown period time were processed by Google Earth engine, JavaScript API, and the results as a spatial temporal analysis indicates that there are a dramatic reduction in the nitrogen dioxide concentration over Mersenne. But due to the fact that having no air quality monitoring station observation in 2019 and 2020, we could not validate the troponin-based nitrogen dioxide concentration and ground station-based nitrogen surface concentration. But as a future work, we will investigate the relationship between nitrogen dioxide vertical column density derived from sentinel bioprecursor and meteorological data. At the end, thank you so much for your attention.
Okay, thank you very much. Is there any question? Is there any question to Fatemeh Kasempour? Okay, if there is no question, we can move to the fourth presentation, or we can go to move to the sixth presentation, I think. And after that, if Professor Kamran is ready, he can continue at the end. Is okay for you, Professor Kamran? Okay, then. So we can move to the sixth presentation. And okay, the Professor Kamran is ready, I think.
Okay.
Are you ready?
No, I am not ready. Our colleagues
okay, then.
not ready to present because we go to another presentation.
Okay, then, no problem. So
thank you.
Thank you for participation. And okay, so we can move to the last presentation, the sixth one. It is going to be done by, not that one, sorry, I'm also at the same time I'm opening. Okay, this one is here. Chapor Anurag.
Yes.
Correct pronunciation?
Yes.
Okay, so you are the last presenter of this session, and so you have, well, I can say that 12 minutes at the beginning, like everyone has, but we can extend a little bit if you like. We are going to have a little bit more time then. So you can start, and would you please introduce yourself before your presentation a little bit? Thank you. You can start. You can share your screen.
Okay. Hello, everyone. My name is Anurag Chapor. I'm a SCGI master student from Wuhan University and Burapha University. Okay, today I'm going to present the estimation of the sky goal by using the nighttime light satellite imagery in northern Thailand. My talk will be divided into 6 parts as follows. Interestingly, less than 10 decades ago, the human couldn't see the specular starry night sky with the naked eye. Nowadays, the people around the world have never seen the Milky Way from their residence, especially in the big city. The massive amount of the artificial light leads the visual improvements of the sea in the starry night. Light pollution is a significant factor for the astronomical observation. In the second half of the 20th century, when finding the new location for the astronomical observation, the astronomers have addressed and concerns about the sky goal because it can limit human visual accurately to see the celestial object and the telescope also. This concept, decommissionation study, used visible infrared imaging radiometer source in the night band observed on SNPP satellite. The method is applied for relativing also optical depth, utilize the contrast almost design area and artificial surface light data. As we know, air pollution and light pollution is recognized nowadays as the global issue with the negative consequences impact in unintended way the nature environments. The sky go occur from both nature and human-made, mostly from light from the moonlight and artificial light. Due to the summer situation, open biomass burning caused air pollution in the northern Thailand. Most northern Thailand was seriously affected by the smoke haze pollution episodes caused by the emission of the forest and crop fire. The study area focused on the northern Thailand, especially during the winter season, is clear sky and low-level aerosols. By the nighttime light looks so good, and the highest sky go effectless in the summer season were associated with the highest aerosol from the biomass burning, such as the image. The bottom scale is a 9-level number scale that measure the sky brightness of the particular location. It quantify the astronomical observability of celestial object and the interference caused by light pollution. This proposed research get straight to the point to meet two specific objects, which are as follows. The first one to transform the night band image data to estimate the sky brightness, analyze the spatial distribution characteristic and the time series of the nighttime light in the northern Thailand between 2014 and 2019. The second tool to estimate the sky go by using the bottom scale model and sky go profile fitting model between winter and summer 2019 in northern Thailand. For the data, I collect both the night band and also optical depth from SNPP vias, and also done the resampling at 500 meter resolution, and then to do the basic georeferencing and convert the radiant to the sky brightness by use the origin law equation, and then analyze the data by use the spatial distribution contrast pattern and time series analysis and linear regression model, and then classify by use the bottom scale model to make the sky go map, and analyze the nighttime light profile by use the profile fitting model, and Serdix model is usually used for the in astronomicals. The experiments and the result of the nighttime light map. The map shows the brightness in magnitude per square axis of the night sky in the northern Thailand. The sky in the urban area of northern Thailand, specifically in Chiang Mai, Chiang Rai, and Lampang, etc., was most lit approximately 16 magnitude square axis. In contrast, the night sky brightness in rural and the forest area was about 18 and more than 20 magnitude axis, respectively. The spatial pattern of a nighttime light time series from 2014 to 2019, the different map increasing 94%. All of this image graph imply the trend of the brightness from 2014 until 2019. The graph shows slightly continuously increases. The diagram shows the spatial distribution nighttime light is present the trend between 2014 and 2019 with a bright tone representing the nighttime light change in more billions. In contrast, orange tone show dim light areas. The bottom scale map present a night scale numerical used to measure the night sky brightness and classify the light pollution level, which each color shades clearly identify the different level of the sky brightness. The SkyGo map in 2019 to show light pollution in northern Thailand. The light pollution between winter and summer, level 1 or the black color considered the darkness is the light pollution free zone, smoothly shown in January, and level 9 or white color in the city of the Chiang Mai regarded as the brightest. Is the highest light pollution zone. In the summer, mostly shown in the level 4 and level 5 of the bottom scales. In comparison, the aerosol optical depth value of the sky brightness in winter was 0.2725, but in the summer value was relatively high, 0.6254 for aerosol optical depth. The SkyGo profile showed the spotlight area in winter had a high brightness value, whereas the dark area had a low brightness value. In contrast, in the summer, brightness value was inversely proportional to winter seasons. The Selig profile fitting SkyGo profile showed correlates with the sky brightness and half-life radius. It can answer the hypothesis. The scatter plot show empirical data and plot the correlation between the radius and the sky brightness at the R-square value of 0.9488, which was considered as a higher correlation. And the correlation between the sky brightness in winter season and the summer season in Chiang Mai is 0.888. Okay, the last section is the discussion and conclusion. In physics, the equation convert radius to brightness was not found. It is possible to convert the value by using the equation based on origin law research. The bottom scale map can apply the identify and specify the degree of brightness and the area affecting light pollution. The SkyGo effect rate in the summer season were associated with the change in radiance over the artificial light source and aerosols. The trend changing mainly in the city center and the rural area. The bottom scale map to compare the light pollution and describe the sky brightness difference in between winter and summer. The image was also interpreted more clearly. The SkyGo profile the effect of the sky brightness in the city center and the typical natural sky were inversely proportional. Finally, the characteristics of the SkyGo and the dark sky were analyzed to configure the relationship and compare the information that can be used to analyze the light pollution of the SkyGo and also optical depth. Thank you for your attention.
Okay, thank you very much for your interesting study and interesting presentation. And is there any question from audience, from participants, other presenters? Okay, I think there is no question. People are do not like to write too much thing. Well, in that case, in this session, second and fourth presentations are missing. I think for the fourth presentation, it's going to be moved some other session as they explain. Then, because of that, I think it's better to closing the session. And the next session, personally, I would like to thank you very much for your participation and for your presentation to everybody who is in this session, also who are listening from the YouTube and participating from different channels, and also here. And I like to thanks also to John for his, efforts for the organizing of this conference. And I thank you personally. Thank you very much for it all. Also to you, John. And the next session will start
10:30.
10:30. So you can participate to the survey and enjoy this session. And tomorrow, I think there is one similar session will be held also. And again, see you in half an hour later, almost at 10:30 in the second session. Thank you very much for your participation. I'm closing the session. Thank you, John.
Professor,
thank you for everyone.
Thank you so much for your nice contribution and being a chair for the very first session of our event. Thank you so much. As the professor stated, the next session will be conducted from 10:30 on surveying and geodesy, and we will have a break till then. Thank you so much. Welcome again, dear participants. In this session, we have 7 presentations, and 7 of them are already here. The surveying and geodesy session will start at the session chair will be Assistant Professor Dr. Mahmut Serbesoğlu from Istanbul Technical University. If he's available right now, I am delivering the session to him. Thank you. Prof, do you have the technical program in front of you?
No, I'm ready now.
Okay, do you have the technical program in front of you?
No. Yes. I have the technical program.
Okay.
Yes,
Okay. The session is yours then. Thank you.
Thank you very much.
And by the way, we have 8 minutes per presentation. 8 minutes. All right? Thank you.
Okay, I would like to welcome you all and our colleagues and the participants to the surveying and geodesy session today of the IGD conference. This is the second session today, and I am Oğuz Serbesoğlu from Istanbul Technical University, Geometric Engineering Department. And our session run from 10:30 to the 12 o'clock. Here in the program, there will be 7 interesting works will be presented, and the presenters will attend from different universities of our country. I would like to also the Professor Can emphasize that the speakers will have 8 minutes for their presentation, and I would be glad if you pay attention not to exceed the time. Okay, today the first presentation from the presenter is Güldane Okutopal, titled "The Efficiency of High-Rate RTK for Structural Health Monitoring." Okay, Güldane.
Hi, Mr. Oğuz. Can I share screen? Okay.
Of course.
Mm-hmm. Hi, my name is Güldane Okutopal. I'm research assistant at Yıldız Technical University. I'm also PhD student. Today, I'm going to present our study about the efficiency of high-rate real-time kinematic for structural health monitoring. I will start with introduction, then brief explanation of structural health monitoring, the network real-time kinematic shake table. Then I will mention about our method and process for this survey. Then finally, conclusion and recommendation. Improving technology, increasing population due to the increased construction, and these areas' largest economy has increased the importance of structural observation and monitoring of engineering buildings, identification of unusual movement, and taking the necessary precaution are very crucial for determination of the disaster risk. So, possible prevention could be taken to reduce big loss. Monitoring of engineering structure should be carried out to check that they have reached or design lifetime, and their remaining lifetime should be determined. Observation of this change on buildings and determination of damage can be done with a systematic structural health monitoring. The purpose of structural health monitoring is to monitor the condition of important structure, to determine natural behavior, and to take necessary precaution in advance by determining possible accident. So, in recent years, global navigation satellite systems are widely used because of their high accuracy and ease of use in structural health monitoring applications. There are lots of concern group for structural health monitoring, but the main on the machinery group, aviation group, and construction group. Thanks to global positioning system, we are in construction group now, like civil engineer. There are lots of engineering structure, but the main of them high buildings, bridge, especially long span bridges, dams, tunnels and excavations, nuclear facilities, and I can say offshore facilities. Okay, there are hundreds of technique and technology for structural health monitoring, especially for different professions, use different techniques. But for our profession, we generally use accelerometer, inclinometer, robotic total stations, GPS, and some hybrid system combination of accelerometer, inclinometer, and GPS. This is one of our professors' works from a hybrid system. But for this study, we just focus on global positioning system in structural health monitoring. High-rate real-time kinematic GNSS measurement method can detect the behavior of engineering structure with high accuracy. So the experiments were carried out with a single axis shake table to determine the performance of real-time kinematic. So the shake table was moved harmonically to simulate possible structural movement, and it's aimed to determine this movement with 20 Hz high-rate multi-GNSS equipment. And real-time kinematic system, which works on the basis of positioning and uses additional phase measurement in addition to code measurement, can determine point positioning in real time with centimeter accuracy. In the network real-time kinematic measurement technique, not from a single reference station, but a system consisting of multiple reference stations. In Turkey, national core-steer system TUSAGA active is operating according to the network real-time kinematic measurement principle, but some other network work in the network real-time kinematic technique, not nationally, but regionally. For example, ISKI UKBS network, they have 10 reference stations active in Istanbul, work in Istanbul. So we use in our measurement, ISKI UKBC network has been used to compare VRS, FKP, and MEC method. The three main techniques, broadcasting, correction, and point coordinates, virtual reference station, field correction parameter, main auxiliary reference station method. The basic principle of VRS method is to create a virtual station in the vicinity of the roaming receiver, and the location of roaming receiver is determined by the help of this virtual station. In the FKP method, surfaces are used as a reference in the calculation of correction parameters. The basic principle of MEC is based on determining the location of the mobile receiver within the network, which consists of one master station and several auxiliary stations. So in our method and process, spectral precision GNSS receiver was mounted on the shake table, single axis shake table, and experiments were carried out in the field of Yıldız Technical University, Davutpaşa campus, Civil Engineering faculty, to determine whether structural vibration can be determined by network real-time kinematic. So a shake table is a platform that relies on harmonic motion at defined frequencies and amplitudes and imitates earthquake movements by artificially generating vibration movements. So the range of motion of the table is determined with the help of LVDT sensor that provide precise positioning feedback integrated into the hardware. The LVDT measures the position of the table at 0.0006 millimeter accuracy with 50 sampling per second. It's very, very high accuracy according to GNSS measurement. So in our measurement, we use LVDT value as a reference value, as a true value. Okay, I want to show a short video from our survey. This is shake table, GNSS mounted on the shake table. The table controlled by a hardware system, specified amplitude and frequencies. This is 5 Hz frequency. It's very high. Okay, data on the movement of selected amplitudes and frequency were collected from GNSS receiver, was stationary and motion. For 3 of them, total 10 minutes, first and last 4 minutes is still stationary, just 2 minutes is motion. So sampling frequency 20 Hz for GNSS, but the motion 5 Hz for all of 3 of them. And I said before, the measurement result compare with LVDT result. Then GPS-derived data were analyzed using time series analysis and fast Fourier transform. In the time series analysis, firstly, the time-dependent graph is graded, then change observed in the increasing or decreasing trend due to any factor are called trend. If there are any trend in the series, by separating this calculated trend from the series, the trended series and graph are created for the VRS, FKP, and MEG method. You can see from the figure. Then the spectral analysis should be done to determine frequency and amplitude of the series. So the transformation of series from a time domain to frequency domain done by fast Fourier transform, FFT. The basic of Fourier technique is based on separation of the signal. In FFT, a function with period t can be approached as sum of sine and cosine function. After the fast Fourier transform is applied to the series, the peak frequencies and amplitude values of the motion and difference from the LVDT is calculated. You can see from the table, first one is the GPS result, second one is the LVDT result, a true result, and difference from GPS from LVDT. The difference is important for us. We compare results according to the difference. So when we look at this result, the best result from network real-time kinematic GNSS method is obtained with the VRS, also MEG method. Lower accuracy was obtained from the FKP method with the highest difference value, their millimeters. Okay, the expected frequency and amplitude of the motion of the stationary time is 0. So we use the stationary time as a root mean square error in our measurement. The lowest RMS belongs to the, you can see from table, VRS 1.5 and also MEG 1.6. And the lowest RMS belongs to the FKP. The RMS results are consistent with the accuracy on the LVDT differences for harmonic motion. You can see here they are same results with the differences. You can see from this figure LVDT and GNSS that trended time series and fast Fourier transform spectra of a representative event. You can see from the figure frequency value for all 3 of them, VRS, FKP, and MEG, same with LVDT result, exactly same, 5 Hz. But some difference in the amplitude value. You can see here some difference. The difference between the amplitude values were determined at 1.5 for VRS, 2 mm for FKP, and 1.4 mm for MEG. So these differences are exceptionally low. In this study, the relative accuracy of the method were determined as below centimeter. Also, the amplitude and frequency values of stationary time are exceptionally low. Since the RMS value and the amplitude of frequency values calculated during the motion are very close to each other, these differences are found to be meaningless. So the nature of frequencies of large engineering structure are in the range of 0.5 and 1 Hz. The determination of oscillation at frequency of 5 Hz with accuracy, high accuracy, a high rate real-time kinematic measurement has shown that the real-time kinematic method effectively be used in structural health monitoring system. In conclusion, network real-time kinematic methods are potentially good method for determining the natural frequency of engineering structure. So all test results reveal that all 3 network real-time GNSS methods are efficient in structural health monitoring studies. Thanks for your attention. My presentation lasts now.
Thank you, Güldane. Thank you and for your valuable work, and I would like to thank the other holders of the study. And if you have any questions, you can ask the participants.
May I ask a question also?
Of course.
Güldane, first of all, I would like to thank your nice presentation. I want to ask a question. Is there any article in the construction specifications of a large engineering projects like dams and so on in our country stating that such monitoring studies should be done by geomatic engineers? Or is it up to the owner's initiative or there is nothing? Do you understand? Yeah.
Yes, we have lots of articles about that. I know also you have some articles for this concept. Can you repeat the main question about icons?
Okay, I am writing here. It's better, I think.
Yes. I will present this. They have high buildings, Istanbul's. It must be somewhere here. I can share. There are, yes, construction specification about that, but especially in skyscraper in Istanbul, Turkey, Büyükşehir Belediyesi'nin
Is it mandatory or not? Do you know?
What?
Is it mandatory or not?
Is for Istanbul, it is mandatory. But I know in last one, GPS system is not mandatory.
Okay.
Yes. Yeah, we try to also compare the GPS system with accelerometer, inclinometer in last specification, but in GPS system unfortunately not involved. Accelerometer, inclinometer, okay, but not GPS system mandatory. Okay. Sorry, I know.
May I ask a second question also?
Yes.
Yes, of course.
You mentioned only GPS rule of your presentation. This means you use just only GPS, or you use the GNSS system, but you mentioned as GPS.
No, we use also accelerometer and inclinometer, no, but for just.
I'm sorry. GPS, GLONASS, Galileo, and Beidou, or
yes,
just
yes,
only
yes.
GPS?
GPS and GLONASS.
Okay. Okay. Thank you very much. Thank you very much.
Thank you, Professor. Thanks for nice questions. Sorry.
Thank you, Güldane.
Thank you.
Okay.
We don't have any question from YouTube, by the way. So in parallel, I checked the YouTube in order to see whether we have questions or not. We don't have any question for this.
Okay, thank you.
Okay,
thank you, sir. Okay, so we can continue. We can continue on the next presentation from Geotechnical University. Yes, Professor Hüseyin Pehlivan will present the analysis process of robotic total station data to determine structural deformations. Okay, you can share your presentation.
Yes, hi everybody. I'm Hüseyin Pehlivan. I work as an assistant professor at Geotechnical University. If you let me, I would like to share my screen. And do you see my screen? No?
No, we cannot see yet.
How can I do it?
By pressing the green button, share screen underneath the panel. Yes.
Okay. It's okay.
Yes. Yes. You can see.
Okay. If you let me, I would like to play the video recording because I'm visible.
Here,
Yes, sir.
Professor, we cannot hear the voice.
Now you are. Do you hear me?
Yes, we hear you, but this is only the video.
My presentation voice.
Yes, we cannot hear enough your voice from
Yes,
video.
yes, my voice is slow. Sorry.
Hüseyin'cim biz hiçbir şey duymuyoruz.
Tekrar başlatabilirim. Video kaydını başlattım hocam.
Ya bundan sonrası en azından zaman bence çok uzatmayalım çünkü 6 dakika geçmiş.
Ha,
En
tamam
azından bundan sonrasını açarsan tabii nasıl uygun görürse sekreteriye ben müdahale etmeyeyim de.
Ya şu anda hiç ses gelmiyor mu hocam?
Hayır, sadece seni duyuyoruz konuşursan eğer.
Tamam hocam. Benim ekranı görüyorsunuz hocam şu anda.
Ekranı görüyoruz ama seni duymuyoruz.
Videoda kaydettiğiniz ses verilmiyor çünkü mikrofonla bağlantılı olmadığı için videonun sesi ses ayarlarında ön bir çalışma yapmanız.
Şöyle yapayım hocam.
O yüzden
bir daha mı başlatayım?
Görüş, yani sadece görsellik görebilir.
Şu anda geliyor mu hocam?
Hayır hocam, şu anda sadece mikrofonunuz bağlı olduğu için videonun sesi Zoom ortamına verilmiyor. Dolayısıyla sizin ya bir ses ayarı yapmanız gerekiyor ya da sunumunuzun eşliğinde...
Tekrar başlatayım hocam. Çünkü o şekilde zaten 8-9 dakika benim sunumum.
İsterseniz sözlü olarak bir üstünden İngilizce özetlerseniz hocam.
Tamam hocam. Şöyle yapayım.
Olur. İngilizce devam edersek sevinirim.
Tamam. I use the different solving method in here. First, the 4 observation equations given in equations 1 and 3 nonlinear function of both parameters and observation. They can be processed by the least square adjustment technique before starting the solution approximate coordinate in here, equation 4, and which the MATLAB program, the elements of the matrix A and can be calculated, and then the positional error at point P can be computed using equation 70, and in order to accept the observation of the P point data coordinate, triangle ABP and its adjusted coordinate to be sufficient accurate, the calculated coordinate must satisfy the coordinate given by equation 80, that is the position change obtained from the coordinate differences between 2 times, such as I and T shouldn't be greater than 3 times the position error. And here we can see the raw and filtered observation data made to point P distance and angle values in here. From robotic total station 1 and 2 were resampled with 1 second and filtered in the time domain. As seen here, the general structure of the data is similar to each other. The adjusted coordinates obtained during the observation period are presented in table 1. Measurement which started at 11 a.m. were completed at 16 p.m. and the coordinate values were calculated every 6 minutes. And Coordinate differences are calculated for each measurement moment in table 2 in here. Since the adjusted coordinate of the peak point provided equation 80, it is accepted as correct. Accordingly, from the adjusted coordinate differences, the total displacement during the observation period was calculated as 1.54 centimeter in X direction and 1.89 centimeter in the Y direction. The total displacement 2.80 centimeters. Now, here the change of the position change with the time can be seen during the observation period obtained from GPS and RTS. Blue colored position changes are the values obtained simultaneously from GPS measurements. Black colored coordinates are also adjusted coordinate values obtained from RTS. It is seen that there are values close to each other in the terms of amplitude size. These results show that RTS measurements can be used as an alternative to GPS in areas where it is easier and more practical to measure. And as a result, it's enough. Thank you so much. It's my presentation.
Okay, thank you for your interesting work, Professor. Is there any question for the study we can take? Okay, thank you again for your work and presentation. We can move on to the next presentation. Professor Rehamettin Alkan, recent advances and perspectives for accurate positioning with low-cost smart devices. You can share your presentation.
Okay, Hüseyin, please shut down your screen. I cannot share my presentation.
Okay, sorry.
Hüseyin'cim kapatabilirsen ben paylaşamıyorum. Şimdi sadece ekran paylaşımını kapatman yeterli. Oğuz, I think it's okay.
Okay,
Yeah.
we can see.
Okay. Dear Chairman, dear distinguished guests, colleagues, hello and good health to all. To you all, I would like to present our study entitled "Recent Advances and Perspectives for Accurate Positioning with Low-Cost Smart Devices." This study was carried out me and my young colleague Can Delice. This study has been organized as you see on the screen. After giving some general information, I will introduce different GNSS positioning platforms, especially the low-cost systems. In the last part, I will end my presentation with some results and suggestions. I have an intention to complete my presentation within 8 or 10 minutes in order to keep the time, the whole of the time. Well, nowadays, satellite-based positioning systems have become the most widely used method for fast, reliable, and accurate positioning in many different areas. With this method, with this GNSS technique, 3D position of fixed or moving objects can be determined in the range of meters to centimeter level, depending on the method used and especially the experimental setups. Global Navigation Systems, or GNSS, refers to a constellation of satellites providing signals from space that transmit positioning and timing data to GNSS receivers. The receivers then use this data to determine the user location. By definition, GNSS provides global coverage. Example of GNSS, mainly USA, now STAR GPS, Russian GLONASS, European Galileo, and Chinese BDS, navigation satellite system. Now you can see the main feature of the global positioning, for global positioning systems. It is routinely possible to determine the 3D position with meter level accuracy by using the code measurements collected with a single GNSS receiver. Unfortunately, this accuracy cannot meet the requirements for many surveying applications that require high accuracy. In this case, the carrier phase observations should also be used. While the handheld GNSS receivers of a few hundred US dollars may be sufficient for the first one, the second one requires multi-frequency, geodetic-grade GNSS receivers, of course, with an GNSS antenna, survey-grade GNSS antenna, whose price can reach up to 10,000 US dollars or even more price. Recently, as an alternative to high-cost geodetic type GNSS receivers, handheld GNSS receivers, Android mobile devices like smartphones, tablet, etc., and OEM type GNSS receiver, which allow to collect and process the raw data, have been widely used in many areas. These types of devices can perform single or multi-frequency pseudo-range and or carrier phase measurements and provide a significant alternative to geodetic GNSS receivers in many applications by providing positioning at different levels as post-mission and or real-time kinematic modes. According to the report prepared by the European GNSS Agency, GCA, it is stated that there are more than 6 billion GNSS receivers currently used on different platforms like tablet, smartphone, digital camera, portable computers, and so on. And this number expected to reach 10 billion within 10 years. Smartphones make up a significant portion of these devices, about 5.5 billion, and it is estimated that this number will reach 7 billion by within this decade. In our study, we reviewed the geodetic surveying performance of different kinds of devices that can be used as an alternative to the widely used geodetic type GNSS receivers. The first one is positioning with handheld GNSS receivers. Handheld GNSS receivers have a large market for navigation, may be purchased by a few US dollars depending on their features. Today, some handheld GNSS receivers can start to log raw data, so the range and carrier phase measurements in RINEX format. In this case, the user can make positioning with centimeter decimeter level of accuracy by processing the collected data. Today, some handheld GNSS receivers can start to log raw data in RINEX format, and user can make positioning with meter to centimeter level of accuracy. Another one is positioning with Android mobile devices. Maybe you know that in May 2016, Google introduced APIs giving access to GNSS raw measurements from Android operating system. After this improvement, user will be able to log GNSS raw data. This opens the possibility to reach low-cost positioning device for Android mobile devices, including mainly smartphone and tablets. The accuracy of measurements made with this type of devices is much lower than it is received with geodetic receivers and even handheld GNSS receivers. One of the main reasons for this is that the carrier to noise density ratios of smart devices are about 10 decibel lower than those of geodetic receivers. In literature, several studies have been conducted on this topic and very promising results have been obtained. This type of device typically provides level of a few meters accuracy and even more depending on the experimental setups and environmental conditions for navigation purposes. However, more accurate results can be obtained when carrier phase measurements are used along with the pseudo range. In general, it has been seen that by processing the carrier phase data collected using devices on internal antenna, the positioning can be made with an accuracy of meters or better. In the case of using a geodetic grade antenna, it is possible to obtain accuracies at the order of centimeter to decimeter as a result of the processing of the code and phase measurement in static mode. Of course, for kinematic positioning approach, lower accuracy are generally obtained. Another positioning platform is, new positioning platform is positioning with OEM type GNSS receivers. The use of low-cost OEM type GNSS receivers began in the late 1990s. OEM receivers with their accuracy have been an important alternative to highly expensive geodetic grade GNSS receivers and have been used successfully in several surveying projects. It is possible to measure and record multi-frequency, multi-constellation pseudo-range and carrier phase data with these type of receivers. However, in such systems, connections between components have to be assembled by user. Besides, lack of easy user interface and the need for users to develop many stages by themselves cause such system to be used only in certain areas. But in general, OEM type GNSS receivers with geodetic antenna can provide centimeter to decimeter level accuracy in static and kinematic modes, of course, if you fix the carrier phase ambiguities. Coming to conclusions, positions data will continue to be more important in many areas and applications on the future as it is today. This means that the need for accurate and fast positioning will continue to increase day by day. Therefore, the production of position data at different accuracy levels will always maintain its importance. Traditionally, high-cost geodetic receivers were required for this purpose. However, in the current situation, new type of low-cost mobile platforms like handheld GNSS receivers, smart device like smartphone, tablet, or so on, OEM-type GNSS receivers have been started to be used as economical alternatives. Indeed, it is possible to determine the position with decimeter or better level of accuracy with these type of low-cost devices possible. The use of these devices will be a serious alternative to geodetic type receivers and will decrease the necessity of geodetic receivers. Low-cost mean the price is below than 500 and at least $1,000. As a future plan, a survey campaign will be conducted using the low-cost device mentioned in this study. I hope I haven't exceeded my time too much. Thank you very much for your interest and attention. If you have any question or contribution, it's most welcome. Thank you very much.
Thank you, Professor. Your valuable presentation and study. And if you have any questions, we can take.
Okay, thank you.
Thank you again. Okay, we can move on to the next presentation from Sinan Birinci. Accuracy of GPS signal point positioning solution using IGS precise products. Yes, you can start your presentation.
Can you hear me?
Yes, we can see your presentation.
Okay, thank you. Good afternoon, Mr. Chairman and dear participants. My name is Sinan Birinci. I am a research assistant at Geotechnical University, Department of Geomatic Engineering. Today, I am going to present my study about the accuracy of GPS single point positioning solution using IGS precise products. I would like to outline the presentation, I will start with the introduction, then the examine methods. Next, we will looking at results, and finally conclusion. Single point positioning is a technique that calculates position information and receiver clock error with only code measurement, pseudo range. In the algorithm, inputs are pseudo range, orbit, and clock offsets of satellites. In the SPP algorithm, broadcast orbit and clock error obtained from navigation message is generally used. However, we used precise orbit and clock data because we used precise orbit and clock because we investigated maximum accuracy in the algorithm. Many factors in the method, in the SPP method, provide these advantages for position accuracy. What are these effects? Tropospheric and ionospheric delay. These effects are also called atmospheric effects. Satellites and receiver clock error. We should also say relativistic clock correction, quality of measurements, orbital accuracy of satellites, number of visible satellites, and geometry of the satellites. The aim of the study, analysis of systematic errors and elimination of their impact on the solution. The maximum accuracy that can be achieved was investigated with international GNSS service, IGS, precise satellite, orbit, and clock products. So contribution of the IGS products to SPP solution, algorithm solution. Examination of epoch by epoch solution according to appropriate weight model. We have come to method section. Adjustment model consists of functional and stochastic model. Functional model matrices belonging to linearized measurement model are shown. The stochastic model was determined according to elevation angle of the satellites. Then, if the number of visible satellites is greater than 4, the unknown vector can be calculated as in the formula, weighted least square formula. We developed in-house MATLAB program for SPP solution. The general structure of this program is shown in the slide. First, the input files were read. Input files are Rhinex observation, clock, orbit, IGS, clock and orbit, differential code bias, antenna, files. Next, preprocessing step. In step, systematic error modeling and eliminating outlier detection. And then process step, we used weighted least square method for each epoch, and results, receiver coordinates and clock offset for each epoch, residuals, GDOP values, visible satellites number. RGS station used in study. RGS station Ankara was evaluated in this study. The selected data ranged from 21 July 2020. The parameters used in the were shown in the table: processing mode, adjustment model, orbit clock, antenna fast center correction, IGS, ionosphere, and troposphere. Troposphere was corrected UMB3M model. Relativistic effect was corrected. Elevation mask set 10 degree, sampling interval 30 seconds, standard deviation of code measurement 30 centimeter. Besides precise product provided by the Center for Orbit Determination Europe were used. 10 days solution. If you look at the graphics, you will see errors of the obtained from epoch by epoch solution for the northeast and up component, and GDOP values and number of visible satellites. I would like to mention 3 critical points here. The degrees in the number of satellites causes the position error to increase. In addition, the GDOP values increases under these conditions. A statistical summary of the processing results. Looking at the table, average position error, root mean square error, and maximum error are seen for each day. Maximum root mean square error is less than 1 meter for all components. It's a very good results because we used only code measurements. Besides, mean east error at centimeter level. And next, ionosphere free code measurement residual. In the figure here, residual for each day were shown in a different color. In addition, residuals were drawn according to elevation angle of the satellites. It's appear that three is clearly a normal distribution, as unexpected. A conclusion: maximum root mean squares error for northeast and up component are 45, 30, and 96 centimeters respectively. It was observed that the daily average errors were maximum 21 centimeters each component. As expected, the up component was calculated with less accuracy than the other components in northeast, according to northeast. It was concluded that the number and distribution of the satellite is important criterion in position accuracy. In future studies, the contribution of the satellite systems to SPP method will also be investigated. GLONASS, Galileo, Beidou, or regional systems. Thank you so much.
Thank you for your presentation, Sinan. And do you have any questions? Okay, we can go on with the next presentation. Improvement of single point positioning, NMA output using projection method from Furkan Soğukkuyu. Are you here?
Yes, can you see my screen?
Yes, we can see you, but we cannot see your presentation. You can share.
Can I start?
No, we cannot see yet.
Please press the green button underneath the panel in order to share the screen. Green button. Yes, now it's okay.
Okay, we can see your screen.
Okay.
Okay, yes.
Hi, everyone. Hi, everyone. Thanks for coming. My name is Furkan, and I am research assistant at the Geotechnical University. My presentation title is Improvement of Single Point Positioning NMA Output Using Correction Projection Method. My presentation consists of 5 outlines. There's DGNSS NMA, DGNSS Correction Projection Method, Study Area and Experimental Setup, Results, and Conclusion. What is differential GNSS? DGNSS, a relative positioning technique, contains 2 DGNSS receivers, one of which is established at the null point. The error between the computed position and the true position is sent to the real-time user via RTCM SC104. The user receiver's position accuracy increases with the correction. In this correction can be applied in 2 days, position domain correction and measurement domain correction. In the position domain correction method, the correction is sent directly as the coordinate difference. On the other hand, in the measurement domain correction method, pseudorandom correction is sent. NMEA 1083. Most of GNSS receivers transmit basic location information and satellite information to the user in the NMEA 0183 protocol, although they do not record the GNSS array data. I will talk about 3 NMEA messages. There's GSA, GGA, and GSB messages. GGA message contains information, position information in SPP solution, and altitudes above mean sea level and geoid separation. GSV message contains the elevation and azimuth angles between the satellites and the GNSS receiver and the signal strength. The satellite ID and deletion of precision existing in the SPP solution are included in the GSE message. DGNSS correction projection methods. The vector line of sight is echoed by the azimuth and elevation angles obtained via GSV sentence. Loss local is converted to a loss ECEF by the rotation matrix that is formed by the receiver's latitude and longitude. The design matrix is obtained from line of sight vectors, and SPP accuracy can be improved by applying position correction to the stand-alone position obtained from GG sentence. Study array and experimental setup. The study array is a Çayırova campus of Geotechnical University to assess the performance of the GNSS correction projection methods. The CHC I-80 GNSS receiver was established at the reference station and U-Blocks elevation kit. Then the U-Blocks elevation kit connected to Novatel FlexBug 4 antenna. Data collection started at the 11:33 Universal Time on the 19 March 2021 and last about 75 minutes with an interval of 1 Hz. At the rover station, the elevation mask is selected at 10 degrees. The reference and rover receivers collect data and runnings and NMA formats. To calculate the design matrix, the position information of the satellites and GNSS receiver is required. There are 2 methods calculating the position of the satellites. In the first method, satellite information, position information is computed using the algorithm for ephemeris determination using by broadcast navigation message collected by the GNSS receiver at the reference station. In the second method, as explained at the beginning of the presentation, the design matrix can be calculated with azimuth and elevation angle obtained via the GSV sentence. results, the processing results are shown table and figure, where the mean error, standard deviation, and root mean square error for the north stop components was estimated from rover station. It's observed that RMS E values obtained from DGNSS correction projection sources were smaller than those of a standalone solution for all three components. However, no significant difference were found between the DGNSS correction projection solutions and the standalone solutions in terms of the standard deviation values. The GNSS and DGNSS correction projection methods give similar results for short distance as is the case in this study. These values revealed that the construction of the design matrix with coordinates instead of local coordinates did not contribute to the solution. Conclusion, the GNSS correlation projection methods provided positioning within meter level accuracy for horizontal components. Since the navigation message did not contribute to solution, DGNSS correlation projection method, the use of the DGNSS correlation projection method with NMI is found sufficient for the estimate of the position with low-cost GNSS receivers. In future studies, the performance of DGNSS projection method will be investigated for the longer distance and the data from IGS precise product. Thanks for your attention.
Thank you, Furkan, your interesting work for single point positioning. Thank you very much. Do you have any questions? Okay, thank you again. And I'm wondering if you use the IGS products. I think this will enhance your results. Thank you again, your good presentation. And the next presentation, the impact of variable neighbor numbers on Wi-Fi fingerprint-based indoor positioning using the KNN and the elevated KNN. Behlül Numan Özdemir. Are you here?
Yes. Can I start now?
Okay, Professor, you can start your presentation.
Thank you. My name is Behlül Özdemir, and I'm a research assistant at the Konya Technical University in Turkey. My talk will be about our research, which is titled The Impact of Variable Neighbor Numbers on Wi-Fi Fingerprint-Based Indoor Positioning using the KNN and VKNN algorithms. The key topics on the screen will be the focus of my talk. Here, I will discuss what position determination in indoor spaces means, as well as the implementation process and outcomes of our research. In cases where GNSS signals are not available or are not strong enough to provide accurate positioning, indoor positioning systems come up as a solution. This is due to the obstructions such as roofs and walls that prevent satellite signals from reaching indoors. Surely, in the case of using GNSS, a location is still obtained, as we can see, but it is not as precise as outdoor applications, and the accuracy fluctuates greatly. For this reason, different solutions are required for indoor spaces. This is where signals of opportunity comes in. SOOP, in its broadest sense, refers to the use of any signal for navigation that isn't usually meant for navigation. Some of these can be seen in the screen. The main purpose of some is wireless communication like Wi-Fi, GSM, or LTE. We will focus on Wi-Fi based indoor positioning in this study. When we look at the positioning accuracy and coverage of Wi-Fi signals, we can see that they have a range of 10 meters to 100 meters and have positioning accuracy of 1 meter to 10 meters. We can conclude from this graph that Wi-Fi technologies can be used for navigation in general. The fingerprinting approach is one of several Wi-Fi positioning determination techniques. Some of its advantages over others are, it is not necessary to know the coordinates of the many wireless access points scattered in the building, and it does not need any additional hardware, for example, to keep precise signal arriving timings, and there is no need for a signal propagation model. However, there is one major drawback, and it is the calibration stage, which is the first of the two stages of the method. In the calibration phase, hundreds of points are marked in the working area and signal strength measurements are made at these points. In proportion to the number of points marked, this stage takes a long time and requires a lot of effort. For this reason, it is important to analyze the position accuracy using fewer calibration points and with the help of some algorithms. Here is the workflow of the fingerprinting method. Fingerprint data collected at each calibration point is recorded in a database. In the positioning phase, the signal vector obtained at a point whose location is unknown is compared with the data in this database, and the position is calculated from the points with the minimum signal distance. If we move on to the application of this method, firstly, this is the building where we took Wi-Fi signal measurements and implemented the indoor positioning method. The methodology was applied as seen. For fingerprint collection and data analysis, we used software that we created. We performed measurements at 237 test points and 1771 calibration points, and the signal strength measurements were completed with the measurement setup by importing the coordinate list of these marked points into the mobile data collection software. Formula 1 is the Euclidean distance used to evaluate similarity, and the Formula 2 is used to estimate the location using the KNN algorithm. Since the position calculated with the Formula 2 is always the exact center of the selected neighboring points, the position is calculated slightly incorrectly. To eliminate this, neighboring points are weighted according to their signal distances, as in Formula 3. If you look at the numbers and graphs, we will see that as the number of neighbors chosen in the KNN algorithm exceeded 2, the average errors increased by up to 6 meters. And more importantly, it is seen that the relationship between different neighbor numbers and the accuracies obtained as a result of the change in the calibration point interval does not change. This is due to the fact that as the search for the nearest neighbor progresses, less and less relevant points are chosen. The VKNN algorithm, which has lower mean errors, produces similar effects. VKNN is rather more effective in this situation because it decreases the effect of less important points on position estimation. When each case is looked at individually, to decide the best point spacing, it is clear that 2-meter distribution has the lowest mean errors. In the second place, distributions of 1 and 3 meter intervals generated the best results. The standard deviations for both KNN and VKNN algorithms can be seen here. The VKNN algorithm generated lower standard deviations in general. Last of all, the calibration process is a crucial step that determines the application's performance. It has been observed that as the number of closest neighbors increases, the point positioning accuracy declines. Higher mean errors are associated with more sparse calibration points, particularly for KNN and VKNN algorithms, because these algorithms use more distant points when selecting multiple neighboring calibration points. Since the nearest neighbor algorithm searches for the point with the lowest signal distance, this point is usually the closest calibration point to it. Therefore, it is less affected by the calibration point density. And finally, it may be better to use dynamic k-value. That was all I had to say on the topic. Thank you for listening.
Thank you very much for your presentation. This is an interesting subject, I think, for indoor positioning. And you have any questions? Do you have any questions? Okay, thank you so much again. Okay, I would like to invite the last presenter. Yes, the title, Brief History of Early Marine Navigation, Hatice Şeyma Selbesoğlu. You can start your presentation.
Can you hear me?
Yes, we can hear you.
Hello, dear participants and professors. First of all, I would like to thank the Honor Board, organizing an executive committee, and I'm glad to be here. I would like to introduce myself. My name is Hatice Şeyma Selbesoğlu. I have been working as a research assistant at Istanbul Technical University for a year. I'm in the master's thesis stage in the History of Science and Technology program. My undergraduate education is on classical philology, especially to cover ancient Roman culture and Latin languages. In this presentation, I will be talking to you about the historical development of early instruments used in marine navigation. Since the dawn of history, mankind has used the sun, the most predictable object in the sky, to determine the time of day and establish direction. Over many millennia, we have acquired knowledge about the positions occupied in the night sky by the moon, stars.
Sorry, do you change your presentation slides? You cannot see.
No.
Okay.
Stars and planets, and have used that knowledge for navigation. The study also includes a brief information as some of instruments that have been used to find the way in the seas. I changed. Transportation has been necessary since the beginning of human history. As people want to move and go to other routes, the history of navigation began. Today, navigation word is used in both sea and land, but navigation term etymologically derived from the Latin verb navigare, which means traveling, especially traveling in the...
We cannot see the next slide.
Oh, sorry.
I think since it's used as a background, now it's okay.
Okay.
Sorry.
Okay, you can continue.
The earliest records of sailing go back to 3500 BC. Since ancient times, the common purpose of people has always been to determine the time more accurately and to find the right route on the sea. Before the development of navigation instruments, sailors used observations as the position of the sun in the sky, the orientation of stars at night, reading maps, almanacs, nautical cards, and using a compass. They noted the positions of the planets day by day and made portolan maps. They used many navigation tools such as crossstaff, backstaff, Kamal, astrolabe, dead reckoning, mariner compass, and mariner clocks. Portolan or nautical maps started to be used at approximately the same time as the mariner compass. These maps don't show lines of latitude or longitude, but are crisscrossed with ramps, diagonal lines emanating from the 32 points of compass roses arranged throughout the map to enable sailors to chart a course to their destination. Over time, the accuracy and efficiency of nautical cards has increased as better navigational tools have evolved, such as the quadrant or cross-staff to determine latitude by the altitude of the sun or pole star. Portolan word is derived from the Italian word portolani, meaning to do with two ports. These marine cards were usually drawn onto a hull sheet of sheepskin vellum. The earliest map of the known world in ancient Greek is made by Anaximander, and this map also separated the nautical parts as days of sailing on the sea. By the 14th century, compass roses were depicted in the earliest medieval portolan cards. The average portolan card had 16 such roses or confluence of lines spaced out equally around the circumference of a large implicate circle. Primitive style compasses were used for navigation in ancient times, and also early nautical maps of the 14th and 15th centuries were oriented by the compass, and all bearings from one port to another were compass directions, and these nautical maps, also known as nautical cards or portolan cards, especially around 14th century. The compass is the iconic navigational instrument. Early navigators looked to the heavens for help with navigation. They found a combination compass and clock. Many primitive timers, such as hourglass, sundial, and candle, were used to determine certain time intervals. The cross-staff was a navigational tool used to measure the angle between the horizon and a celestial body, such as the sun or stars. By knowing this angle, a navigator could then determine his latitude and direction. The cross-staff is also referred to as the forestaff and the Jacob's staff. The principle of the cross-staff dates back to the Chaldeans, an ancient people of Mesopotamia, present-day Iraq. Invention of the traditional cross-staff for use at sea was inspired by Kamal, a navigational tool often used by Arabian people. Dead reckoning is one of the primary and oldest methods of marine navigation. Dead reckoning, that preferred method when celestial observation is unavailable, is a method of navigation relying on estimating one's current position using a previously obtained position. In earlier versions of reckoning, during the cruise, a floating object was thrown into the sea from the fore, and the time of this object until it reached the stern of the ship was determined. An armillary cipher, also known as spherical astrolabe, armilla or armil, is a model of the celestial cipher invented by Greek mathematician, geographer, and astronomer Eratosthenes in 255 BC. He made several important contributions to mathematics and science. Eratosthenes is calculated the Earth's circumference. 240 BC. Using trigonometry and knowledge of angle of elevation of the sun at noon in Alexandria and Siena, now Aswan, Egypt. He also made a map of the entire known world. Besides him, only Hipparchus, Strabo, and Ptolemy were able to make more accurate maps in the classical and the post-classical world. Name of this instrument, invented by Eratosthenes, comes from the Latin armilla word, meaning circle, bracelet, because this instrument has a skeleton made of graduate metal circles linking the poles and representing the equator, the ecliptic, meridians, and parallels. In larger and more precise forms, they were also used as observational instruments, being preferred by Ptolemy. The astrolabe, which dates to the later period, is a more portable version of this instrument, so it has become more accurately working in use marine navigation. What is the working way of armillary sphere for navigation? It is simple. The sphere determines the declination of the sun. The date is marked around the equatorial and ecliptic rings. For each day, determine the solar declination as the angular distance on a meridian between the ecliptic ring and the equatorial ring. Use an astrolabe to determine the altitude of the sun at its highest point at noon and calculate your latitude. Ptolemy had described in his study Mathematica Syntaxis, or also known Almagest, El-Megisti in Arabian, comprising 7 interlocking graduated rings representing the fundamental circles of the heavens. All measurements and calculations were made according to the geocentric system until the scientific revolution in the 16th century and Copernicus's work. Meaning of astrolabe word is star catcher in Hellenistic Greek language. The mariner's astrolabe let sailors find their latitude while traveling far away from the sight of land. A mariner would hold the astrolabe up at noon so the sun shone through its 2 sides. The sailor would then read the scale to determine the sun's altitude and consult a table of the sun's daily declination to determine the latitude of ship. Mariner's astrolabe is also the basis of marine chronometer. A quadrant is an instrument that is used to measure angles up to 90 degrees. It was originally proposed by Ptolemy as a better kind of astrolabe. There are several different variations of the instrument, such as geometric, David's quadrant, and Sinecal quadrant, also known Rubul Mujayyab in Arabian language, especially used by sailors and navigators as type of quarter of an astrolabe. This quadrant type, also known al-mukantar. When in use, the navigator would say north or south until the quadrant indicated he was at the destination's latitude, turn in the direction of the destination, and sail to the destination, maintaining a course of constant latitude. In this study, main issues were how navigation in the sea emerges and develops, especially scientific instrument stations found in classical text in Greek and Roman are worth examining. Thank you for listening.
Thank you, Şeyma, for your presentation about the history of navigation in marine navigation. And do you have any questions about the study?
I have sent a question.
Yes.
In the chat.
Can-
Thank you.
Yes, Professor.
If you know, but if you don't know the answer, just skip it. But I just ask because we find Latin and Greek at philolog here, so I'm very curious about the answer of this question, if you know. But if you don't know, never mind.
I don't understand your question.
Okay, your question is written in the chat, Şeyma. Which word is etymologically more ancient in Latin and Greek languages? La mappa or la carta? Which is the more ancient?
Mappa.
Mappa.
From Mappa Mundi.
Mappa Mundi. So the mappa is older than La Carta, right?
Yes, yes, yes.
Thank you. Thank you.
Thank you for contribution, Professor. Okay, we in our session 7 studies have been presented, and I would like to thank all presenters and the participants, all audience for their contributions to the conference and our session. And then after our session, the lunch break will start. We have a break, and I would like to give the say to Professor Can.
Thank you so much for being a chair for this session, Professor Salvesolo. And I would like to congratulate and thank you for your contributions on behalf of my team. And for the other presenters also, I would like to congratulate them and thank you so much for your participations. And the next presentation will be, the next session will be held by 12:45 after lunchtime, and enjoy the lunch. Thank you so much. We can close the session.
Yes, Professor. And also, I would like to thank the organization, the executive committee of the conference. Thank you, your great efforts, Professor.
Prof. Şanlıoğlu, would you like to add some comments, additional things before closing the session? Could you open up the microphone, please?
Okay. Thank you very much for participations and presentations. It's a very nice session, and I wish all my colleagues and participants come again the other symposiums. Thank you very much.
Thank you so much, Prof. You too. So I think we can conclude the session.
Okay.
Thank you. Have a nice day.
Thank you. Have a nice day.
Thank you so much.
Welcome back again, gentle participants. We will start Geographic Information Systems and Cartography 1 session. I will chair this session, and in this session we have 8 presentations till 14:15. So I would like to invite the first participant, Mr. Tariq Islam. Can you hear us?
Yeah, I can hear you.
So his presentation is entitled as a quantitative approach for geographical vulnerability assessment of Bhasan Char, Bangladesh using remote sensing and GIS. So, sir, please share the presentation with us. Thank you.
Thank you very much. Can you see it, please?
Yes, you can. Yes.
Thank you very much. Yeah, this is Tariqul. I'm the Tariqul Islam from the University of Nottingham, UK. I'm going to present a quantitative approach for geographical vulnerability assessment of Bhasan Char, Bangladesh, using remote sensing and GIS. I have two co-authors, Muhammad Tariqul Islam from Swedish Maritime Administration and Huddinge municipality in Sweden. The background of this study actually Rohingya refugee in Bangladesh, and Rohingya is a minor Muslim ethnic group in Myanmar. They have been facing migration, forcefully migration to Bangladesh, mainly Bangladesh, and also to the other countries in the world since 1970s as an ethnic cleansing. Recently, 3 months, September to November 2017, 742,000 Rohingya people migrated to Bangladesh, and now more than 1 million refugees live in camps in Cox's Bazar district in Bangladesh in humanitarian conditions. Bangladesh government constructed a $274 million housing project at Bhasan Char for 100,000 refugees to improve their housing situation. Bhasan Char is island, is about 40 square kilometers, consists of 120 cyclone shelter from school, medical center, community center with 2 helipads, and housing blocks built up above 4 feet concrete structure from the ground level. Bhasan Char is located at the mouth of Ganga Brahmaputra Meghna river system in Bay of Bengal, and it is a sandy island with an average altitude of 2.8 meters from the sea level, and it was not exist even to 20 years back. So this is very newly formed island and very susceptible island, formed between 2005 to 2006. Many claims that it may be eroded or washed away by a strong flood and cyclone. So our task here actually to assess Bhasan Char geographical vulnerability. And this is you see the map here. Here is Myanmar, India. Here is Bangladesh. This is the mouth of the river system, and this is the tiny island. And here is Bhasan Char. Here is different island. I'm going to explain the details. Method. Geographical vulnerability is assessed by quantifying how often the nearby islands is eroded and deposited, since this Bhasan Char was not exist 20 years back, despite some natural calamities like severe tropical cyclones. Landsat remote sensing data from 1975, 2000, and 2020 were used. Images were processed by applying normalized different water index just to differentiate land area from the water, and further they are classified and quantified shoreline changes. This is you see the Bhasan Char. The total area is about 40 square kilometers. but the habitat area is only about 7 square kilometer, and this is protected by, we see the magenta color embankments, 13-kilometer long flood protected embankment, and there is a 3 meters high. And here is some photograph. You see the housing blocks here. This is sandbag to protect the island, and this is some metallic infrastructure to protect from the tidal wave. And here is the mouth of the river system with the tiny islands, a lot of islands actually. And this one is Bhashansor, you see, an unnamed shore here, unnamed island is see here. It was not almost visible in 1975, but it's gradually increased and migrated to the southeast. You see here, and the rate is 375. And Hatia Chor is here. This one is also migrating toward the south. And here is Shandip. You see here is migrating towards the north. So this is actually very dynamic area, and this controlled by somehow siltation and the flow of the river. So siltation and flow of the river is going like this to the east, southeast, and then forming some kind of island, and they are moving apart. So this is very dynamic area. It's not static, and in fact, this is vulnerable. And this is also area for cyclone prone as the geographical location. Nowadays, see severe tropical cyclone hit in Bangladesh and in this area, in fact. But the good news is that they have cyclone shelter and is for 833 person. On the other hand, the host community, Bangladesh, has only 1,000. So this is the positive thing, but the embankments need to 6 meter high. And the 100,000 people will be increased in a vulnerable group in Bangladesh. So this is actually a temporal solution, but the geopolitical behavior between Bangladesh and Myanmar is very complex. Therefore, the refugee live since 1970s. On the concluding remark, I would like to say, I mean, as a temporal basis, as a temporal solution, is maybe okay by maintaining some engineering work. But the most important thing is need to investigate more about sustainable concepts like income opportunities, environmental issue, social linkage among the refugees in Bhashansar and the camps in Coxbazar. Thanks for your attention. If you have any comments or questions.
Mr. Islam, thank you so much for your nice contribution. Actually, it seems that the vulnerability of the coastlines.
Yeah.
Actually, your title is Geographical Vulnerability Analysis, and I was expecting something more broad in terms of geography. But I think that your title can be converted to coastline vulnerability. Do you agree with me?
Well, it could be, but the problem is I just want to assess here that the location in terms of erosion and deposition, and that's actually specified in the objectives.
Okay, because in order to attract the readers or in order to have more citations for your work, it could be better maybe if you would add more specific terms for your work. So that's why I was trying to add this comment. So thank you so much. It has been a nice contribution. Thank you.
Thank you very much.
The next presentation will be conducted by Mr. Halit Altun. Am I right? Yes. And whose paper is entitled as Accuracy of Digital Elevation Models Under Canopy versus Open Field. So please share the presentation with us. By the way, Mr. Islam, could you unshare? Okay, thank you. Mr. Altun,
Yes. Hi, everyone. My name is Halit Altun. I'm doing my master's at Kastamonu University Forest Engineering under the supervision of Arif Ağuz Altuner. And this is my presentation. And the presentation is about accuracy of digital elevation models under canopy versus open field. So I would like to start with what's the digital elevation models. They are made up of squares which have their elevation values in, and you can see on the left side the numbers on the squares, and on the right side this is most commonly visualization of dams under ArcGIS softwares, and they are representation of topography. The fields, the areas relating the topography, they use most commonly used dams. So the examples, the natural resources, engineering, disasters, and risk analysis, topographic mapping, landslide and flood analysis, forestry, etc. And list goes on. Yeah. And these elevation data are captured by remote sensing capabilities. And these remote sensors can be either active ones or passive ones. Active ones can illuminate their target areas, while the passive ones cannot illuminate their target areas. They need another light source. And there is the problem here. These sensors have a hard time getting the elevation data off the ground because of the objects on the ground, and forest vegetation is most common obstacles among these objects. So we tested how accurate they are under forest canopy. In this study, we tried to figure out how much effects forest vegetations have on elevation values of most acknowledged dams. We tested SRTM C-band, X-band, ALOS pulsar, AV3D30, and ASTER version 3. We tested, we compared them to real-time kinetic GPS points. And here is the study area. The study area is in Kastamonu province in Turkey. It is a dam reservoir. And these real-time kinetic GPS points gathered by the governmental institution relating water resource management, which is known Devlet Su İşleri in Turkish. And here you can see the yellow dots are the RTK GPS samples. Black polygons are forest canopy. Purple polygons open fields. We selected these areas using Google Earth. Open fields are mostly agricultural areas. And here is some information of our sample sites shown in this map, and the information, their areas, and the number of points of real-time kinetic GPS points which in our sample sites, and their density in hectare, as you can see. And we used root mean square error equation to evaluate how much different the value of the dams from the real-time kinetic GPS points, model values as dams, and observed values as real-time kinetic global positioning system. We used ArcMap 10.5 to process the data. Here you can see the yellow dots, real-time kinetic GPS points. We used point to raster tool to generate a dam from these points. And we selected 22.7 meter length, one side of the square, because most of the dams we tested matched with this close to this number. And then after we generated the real-time kinetic generated the dam real-time kinetic GPS points, we generated points, systematical points from the RTK GPS dam, and then we used the tool extract values to 2 points. So we put these points on the dams we wanted to test, like SRTM C-band, X-band, ALOS pulsar, etc. And in the attribute table, we get their elevation data according to these systematical points. So we get the RTK GPS points elevation and their elevation value from the dams we want to test. And then we extracted this attribute table in the format .xls, which is Excel format, and we calculate the root mean square error value using Excel. And here is the results, our results. SRTM C-band, X-band, ASTER version 3, and you can see that under forest canopy, the dams performed worse than the open field. You can see that root mean square error value is bigger than the open fields, but with the exception of 2 sites, and the open field for sample site for ASTER version 3 and ALOS pulsar sample site forest canopy sample site 3. SRTM C-band, X-band, and ALOS pulsar are using microwaves for elevation data gathering. So they are active, they have active sensors. And it was shown that longer wavelengths of microwaves penetrate vegetation to a far greater extent. C-band, and you can see the intervals of the wavelengths here. X-band has the smallest wavelength, and as you can see that X-band has greater value of root mean square value. But in this particular area, Lie-band, ALOS pulsars are using Lie-band wavelength and have the largest wavelength. But in this particular area, root mean square of the ALOS pulsar is greater than SRTM C-band, as you can see. And ASTER version and AV3D30 utilized stereo correlation to produce them by using stereo pairs. They are passive sensors. And AV3D30 performed better than ASTER version 3. And its results were very similar to the SRTM C-band, as the recent study suggests, done by Gonzalez Morales, VVM 2020. Overall, in conclusion, almost all of the dams performed worse in under forest canopy versus open fields, with the exception of 2 sites, of course. In future, this kind of study should be done in bigger areas, and more remote sample size to each other should be selected than the sample size in this paper. Thanks for your attention.
Thank you so much for your presentation, Mr.
Khalid.
Actually, we have a question, and I wrote it down to the chat panel. Could you read it? What is the final spatial resolution of generated DEMs?
Spatial resolution is 27. 22.7. Pardon, 22.7.
22.7
meter.
Meters. Okay, thank you. Is there any other question from the other attendees? And let me check whether there's a question on YouTube. I think no. Actually, I would like to add a comment for your work. In the future studies, you can compare the data sets in order to generate a DEM with the same spatial resolution. Because sometimes the spatial resolution, even though the spatial resolution is the same, but the sensor's quality is also important. So if you want to compare the quality of the sensor to generate a qualified DEM, I recommend you to compare this kind of parameters for a future study. Thank you so much.
Thank you. Thank you.
The next presentation will be conducted by Fatma Bünyan Ünel. Is she ready?
I'm ready.
Okay. The topic is geostatistical mapping of reference crop evapotranspiration. Can you share the presentation with us? Good luck. Thank you.
Şöyle. Sorry, 1 minute. Tamam, oradan bitirin de ses görüntü açacağım. Sorry. My name is Fatma Bünyan Ünel. I'm a lecturer in Department of Geometric Engineering in Mersin University. My topic is geostatistical mapping of reference crop evapotranspiration. On all the world, soil and water are the most important sources. Their sources are scarce. Their sources cannot be derived. These sources are important. 70% of the Earth's surface is covered with water, but the amount of natural spring water available is approximately 2.5%. Normally, fresh water makes up a very small fraction of the Earth's water. 70% of the natural spring water is used in agriculture. The demand for water in the world is increasing day by day due to the increase in population, global warming, natural disasters, and environment polite, etc. The study area is located in Mersin. The area characterized by Mediterranean climate, which is hot and dry in summers and warm and rain in winters. There are 28 meteorological stations. This is used 10 criteria. For example, maximum temperature, minimum temperature, maximum and minimum related humidity, wind speed, the other as seen in the table. 28 meteorological stations, information and their date were obtained from Meteorology Mersin Provincial, the director. The meteorological date where it belongs to a total of 28 stations, 15 in Mersin and 13 in neighboring provinces were arranged. In the content is a method adopted by the United Nations Food and Agriculture Organization 98. The guidelines are presented for competing crop, water, irrigation, and drying people know 15.6. Science
Prof, your presentation, your speech is lagging. Could you wait a bit? Stop for a while. Are you with us again? Can you speak again? Could you say something? Okay. Okay. Okay. And now share your presentation again, please.
Thank you.
Because your connection was slow. So we need to stop for a while and we can continue right now. Thank you.
I'm sorry.
Don't worry, you can continue now. Thank you.
Thank you. I'm continuing. Okay. Since it's the closed method to real measurements made with lysimeter, see following equation. It has a complex structure due to interlocking calculation. It's hard programming this equation. Reference crop evapotranspiration was calculated by the Penman-Montaigne method with the help of MATLAB software. In the 2018, there was a greater need for water than others. For each of the 28 meteorological stations, the days of May 1, 31 were found between 2017 2020. for Çamlıyayla, Toroslar, and Ulukışla districts, there is a consistently low water need every year. These maps in Mersin AT0. First, in left, first map is 2017. Mersin province and district borders and 28 meteorological stations were transferred to ArcGIS 10.5 Geographic Information Systems software in order produce the statistical map of AT0. Separate map of each day of May can be created, but this map is seen 1 May. However, in this study, maps of reference crop evapotranspiration were prepared for the years 2017-2020. First, A is 2017, B is 2018, C is 2019, last map is 2020. It was used cracking, which is one of method of geo-statistical analysis. Not all color in legends appear on the maps because the geostatistical map is arranged according to Mersin province's border. The basic requirements of the world's population are water and food. Agriculture areas need to be cultivated, planted for food production. It's known that most of the water consumption is used for agriculture purposes. For this reason, planning of crop evapotranspiration is of great importance. In future studies, the AT0 value estimated using the Penman-Montaigne method can actually be compared with the AT0 value optimum from the measurement result using the Lisimeter. AT0 can be predicted using modern methods. Its references. Thank you.
Thank you so much for your nice presentation, Professor Ünal. If we have any question related with the presentation, I think no. So we can continue with the other one. The following presentation will be conducted by Mr. Aydın Alptekin on mapping of local soil conditions in GIS environments, a case study in Çukurkeşlik village. So, Prof. Ünal, please unshare your presentation. Okay, Mr. Alptekin, can you share the presentation with us? Thank you.
Good afternoon, everyone. Do you hear me?
Yes, but if your microphone is closer to your mouth, it would be better.
Now, do you hear me?
Now it's better. Now it's better. And could you make your presentation on full screen, please? F5. F5. Yes. Thank you. Go on, please. Thank you.
Good afternoon, everyone. I am Aydın Altekin, a research assistant in Mersin University. My topic is mapping of local soil conditions in GIS environment. New settlement areas are needed parallel to the population growth. It is essential for the city planners to know the local soil conditions of the area before starting construction works in a region. Planning of settlement areas is useful in determining possible problems that may be encountered later. Turkey is located on active fault zones and exposed to natural disasters frequently. Earthquake is one of the leading disasters that result in death. Seismic microzonation studies should be carried out in the geographical information system environment using geological, geophysical, and geotechnical studies in order to minimize the loss of life and property from earthquakes. Generally, attention is not paid to the engineering properties of soils in underdeveloped countries. This situation causes natural disasters to result in loss of life and property. The physical properties of the environment where earthquake waves affect the degree of damage in buildings. Therefore, it is vital to know the engineering properties of soils. In the study area, the Geological Geotechnical Survey report was prepared by Yenişehir Municipality in 2017 as a basis for the development plan was used. Landslide event has been seen in the study area. We used the engineering properties of soils obtained from drilling and seismic investigation results. Atterberg limits are the critical water contents of the soils. Liquid limit is the water content that the soil changes from plastic state to liquid state. And the plastic limit is the water content that the soil changes from semi-solid state to plastic state. And plasticity index is the difference between liquid limit and plastic limit. In the study area, there were 6 boreholes, and disturbed soil samples were taken from nearly 2 meters depth. Liquid limit and plastic limits were performed. Liquid limit test results are nearly 42%, while plastic limit tests were nearly 23%. According to the plastic chart, all of the soil samples belong to CI group, which means clay with intermediate plasticity. In the study area, geophysical survey was carried out. The main aim of multi-channel analysis of surface wave technique is to measure S-wave velocity. VS30 values were measured accurately. Low frequency geophone with 12-channel seismograms were used. According to the MEASP results, ground dominant vibration period, average shear wave velocity at the top 30 meters of the soil, and soil amplification values were determined according to the 5 locations. Then soils were classified according to the results. In Europod classification, soils belong to B and C group, which means B is hard soil and C is soft soil. And according to the National Earthquake Hazard Reduction Program, all samples belong to C and D group. C means hard soil, D soft soil. The obtained engineering properties were mapped in ArcGIS software by using spectral analysis model. Inverse distance weighted interpolation method was used. Atterberg limits distribution maps, liquid limit and plastic limit were prepared. VS30, T0, and soil amplification values were also met. According to the liquid limit distribution map, the highest point is at the center part. According to the plastic limit distribution map, the highest point is at the center part. According to VS30 distribution, the highest one is southeastern part. According to T0 distribution, the highest one is at the western part. And soil amplification distribution one, the highest point is at the western part. In this study, the changes in local soil conditions were investigated. Local soil conditions are one of the most important factors that cause damage to the buildings. In future, it was planned to prepare microzonation maps in this village. Thank you for listening.
Thank you so much for your presentation, Mr. Altekin. I would like to congratulate you about your accomplishment in this study. If you have the participants, if you have any questions, you can write down in the chat session. And let me check also the YouTube for you. I think not. Okay. The next, thank you so much again, Mr. Artekin. The next presentation will be conducted by Mr. Abdulwahid Chow. I'm not quite sure about the pronunciation of the surname. If I do it wrong, please pardon me.
Hello, hello everyone. Do you hear me?
Okay. Can you share the presentation with us?
Okay. Second minute, please.
Yeah.
You can see my screen now?
Yes, we can see, but if you do it on full screen, it would be better to see.
Now it's better?
Yes, definitely. Have a nice presentation. Thank you.
Thank you so much. So first of all, I would thank the organizer of this International Days and for inviting me here today. I'm Abdulwahid Chow from Morocco, and I'm a PhD student at the Agriculture and Veterinary Institute in Rabat. So my presentation today is about using an integrated approach for mapping soil sanitary risk in Tedla Plain, Morocco. This presentation is structured as follows. Firstly, I will start by a short introduction. Secondly, I will a brief description of the study area, method, result, and discussion, and I will close this presentation by a short conclusion. So, soil salinization has been identified as the main cause of land degradation especially in the irrigated area, and this phenomenon is negatively affect the sustainability of agriculture by reducing soil and water quality and limiting agriculture productivity. Each year, soil salinization remove up to 1.5 million hectare and reduce the production by up to the 46 million hectare. In our country, since the equipment of the irrigated area, about 16% of irrigated land was affected by secondary salinization. In Tedla Plain, the increase of groundwater and surface water coupled with the intensification of agriculture activity leads to soil salinization and weakening of regional agricultural production. So soil salinization is a complex phenomenon related to several factors such as soil factor and the management factor and the climatic factors. Our study area this study is looked out in the irrigated perimeter of Tedla. Extend this area extend over average area estimated at 2,600 square kilometer. This perimeter is crossed by Omar River over approximately 116 kilometers, which divided into sub-perimeter with different hydraulic characteristics. Bnamir in the north and Bni Musa in the south. Geologically, the tadlak perimeter is characterized by a vast sanctuary depression weighted with Newsen and Quaternary deposits. On the level climatic, the tadlak plain is characteristic by a semi-direct continental climate with ambient rainfall varying from 150 to 450 millimeter and anterior coefficient of variation of 20%. The rainiest month is November, but secondary maximum is recorded in March. Minimum and maximum temperature are recorded respectively in January and July. So as I said, the main objective of this study is mapping the risk of salinization in tadlak plain. So we adopted the soil salinization risk index. This index integrates soil property, topographic and climate, and water and soil quality. This method is an additive method. Each factor are manipulated by their weights, and weighted value are added together in order to estimate the salinity risk, which varied from 10 to 15. In its each value are depending on the class of risk. Data used in this study are collected from the monitoring network for water and soil quality in tadlak plain. This figure showed the representation of all sampling collecting from this network. So before elaborating or estimating the risk index, all data are processing and spatialization in an SIG environment, especially in we use ArcGIS, and we use inverse distance weighting method for spatialization, depth of water table, electrical conductivity of irrigation water and of the groundwater, and electrical conductivity of soil. In our study in tadlak plain, the electrical conductivity of soil are shown variation very important, especially in Ibn Amir, which show more concentration of salt than those of Bni Musa. And generally, this electrical conductivity is varying progressively from the upstream to downstream, where we have the more concentration in this salt element. In Ibn Amir, the salt concentration that we see now is can explain it by the use of saline water of Rabi'a River for irrigation in this area, and by the intensification agriculture in this area. Also, the electrical conductivity of groundwater, we can see that they show the variation progressively from the upstream to downstream in the tadlak plain, and we can notice that the concentration of water soluble salts are more significant in Ibn Amir, and this water seems to be affected the most by salt. The concentration of salt is low in the eastern of Bni Musa, but increases progressively toward the west to reach a maximum in the downstream. This can also explained by the intensification of activity, of agricultural activity in the Yemen, and the increased use of fertilizer also by the absence of the system drainage or system lynching. Depth water table also show great spatial variability within the Tedla irrigated perimeter, and it's deeper in the northern Binyamir and the western Bimusat, where the depth can exceed the 20 meters. The table drawdown is essentially controlled by the regional rainfall regime and the withdrawal of irrigation water in Tedla plain. Soil texture analysis of Tedla perimeter allowed identifying three major categories, which are moderately fine, fine, and very fine. Moderately fine texture soil with the moderate rates dominant with 64% of the total area. Topographic factor. We use slope to express the variation of topographic factor in our study, and the spatial distribution of slope class showed that 85% of the irrigated perimeter is characterized by slope class of 0 to 1%, while the remaining 20% is described by a slope ranging from 1 to 5%. The analysis of salinity risk also associated with the terrain slope shows that the lower its slope class, the greater is the associated salinity risk as external drainage becomes deficient. To identify the climate and to integrate this factor in the index, the aridity index are used in this study, and generally Tedla plain is an arid environment with a severe salinization risk. Electrical conductivity of irrigation water generally we can notice that the water of Omrabe are very saline, more than of Bilwiden water that's used for irrigation, especially for irrigation area in Bimusa. Geologically, we don't. In this context, geology was considered not having any impact on this salt content in the Tedla plain. Absence of salt dams and overboard, thus lowering the risk of salinity. As a result, we can the soil salinization risk map we can notice that this map we can notice the for major class: moderate current risk, severe current risk, low potential risk, moderate potential risk, with the predominance of the moderate potential risk, which characterize the area can be sensibly for salinization in Tedla plain. And severe current risk characterize the area with a high value of electrical conductivity of groundwater and soil in the downstream. As a conclusion, we demonstrate demonstrate the interest of using the soil salinization risk and its approach in the integration of multi-source data for the characterization of soil degradation risk by salinity in the irrigated perimeter of Tedla, and also for the best management and the best management for this area. Understood and monitoring the spatio-temporal dynamic of soil salinity is the key to understand the impact of rainfall irrigation and agricultural practice and devolution soil salinity. As a recommendation, we recommend also to the integration the more factor dynamics, such as the effect of crop through land cover or land practice in this index. And thank you so much for your attention.
Thank you so much. It has been a nice presentation about a pivotal country and a very important topic. Actually, during my PhD studies, I was working also on soil classification maps, and I would like to congratulate you. And I found you so lucky to find such huge data sets about the electrical conductivity and so on. Actually, this is a very vital and important issue, to have a huge and variable data sets. So it is very important. But I would like to add something. Instead of using inverse distance weighting, I think in order to make your work in a more modernized way, you may try other prediction and interpolation algorithms, like artificial intelligence and machine learning methods, and changing the hyperparameters of these algorithms. Because EDW is a bit, let's say, I don't want to kill it, but it's kind of old way to interpolate. So the literature, recent literature focuses on more artificial intelligence, deep learning algorithms to interpolate and predict the unknown locations. So I recommend you to do this, but your data sets, it's so valuable and it is not so easy to obtain such a huge data set, especially for the soil classification maps. Thank you.
I would also to add that right now we working at the use of a logic flow to estimate and to use this data in order to estimate and mapping the risk of salinity in this data. So this work is actually all in the same time we say to analyze data and to export something with this data, and this is the first step. So this is the first step. So another work is we are working right now is how to use as I said the logic flow in the to mapping the
for the following results, please share with us in our following conferences. Thank you so much for your contribution, and give our regards to those Moroccan colleagues there. Thank you. The next presentation will be conducted by Mr. Aslan Cihat Bashara on GIS-based landslide susceptibility mapping using weight of evidence and random forest. So have a nice presentation. Thank you.
Hello, I am Aslan Cihat Bashara. I will present our study titled GIS-based landslide susceptibility mapping using weight of evidence and random forest. Disasters are events that cause material and moral damages in the society. They affect and cause great problems in terms of the consequence they cause in the flow of daily life. The landslides can be defined as the downward movement or sliding of parts, such as soil and rocks, under the influence of gravity or external factors, such as earthquakes and continuous rains. When the negative effect caused by landslides are carefully examined, it is necessary to first reveal the spatial distribution of existing mass movements and inventory information. Using the available inventory data, landslide susceptibility analysis, risk and hazard values can be determined. For the landslide susceptibility analysis, Tokat, Turkey province was determined as the study area. Material and method. There is no standard for the parameters to be used in landslide susceptibility analysis studies. Therefore, the parameters may differ depending on the area to be studied. When the parameters used in the landslide susceptibility analysis were analyzed statistically, traits in table were obtained. The slope, aspect, elevation, land use, geology, fault lines were selected as parameters for the study. The data of the material used in the study were processed using the weight of evidence method and random forest algorithm. Material. Slope map. The slope map was created by dividing into 7 classes. Aspect map. The aspect map was created by dividing into 4 classes. Elevation map. The elevation map was created by dividing into 7 classes. Land use map. The Korean land use map was created by dividing into 9 classes. Geology map. The geology map was created by dividing into 10 classes. Fault lines map. The proximity to fault lines map was created by dividing into 5 classes. Inventory map. The landslide inventory map was obtained from the TC Disaster and Emergency Department. Method. In the study, obtaining the landslide susceptibility map was applied in 2 stages. In the first part, the weight of evidence method was applied. In the second part, the weight of the parameters are determined by the random forest algorithm. The data obtained from the analysis result were included in the full text as tables. Weight of evidence method. The relationship of the parameters with the landslide inventory map was determined using the weight of evidence method. Maps were reclassified according to the analysis result. A value equal to 0 indicates that the subcategory of the factor causing the landslide is not important for the analysis. Positive contrast indicates a positive positional relationship. Negative contrast indicates the opposite. Random forest algorithm. Random forest method is one of the collective learning algorithms based on using many decision tree models together to solve a specific classification and regression problem. The algorithm is based on the principle of combining the estimates made by each of the decision trees that make up the forest and making the final decision for the relevant sample in the process of estimating a sample with an unknown class label. Result. Landslide susceptibility map. The landslide susceptibility map was produced in 5 classes: very low, low, medium, high, and very high. Discussions and conclusion. When susceptibility classes are examined, it was seen that 92.42% of the old landslide event occurred in high and very high class. 7.33% occurred in middle class, and 0.25% occurred in low and very low class. In the spatial analysis of landslide events, it was seen that the susceptibility classes are examined spatially. High-risk areas constitute 67.77% of all areas. Medium-risk areas constitute 21.58% of all areas, and low-risk areas constitute 10.65% of all areas. As a result, it is possible to say the following Susceptibility mapping is very important to prevent material and moral losses. They may occur due to disasters. Thanks for listening.
Thank you so much, Mr. Bashar. I have received 2 questions from the participants. Actually, they are asking the coding environments. Where did you code your algorithms, both for weight of evidence and random forest? In which programming language, in which software package did you code your algorithms?
Random forest algorithm process RStudio. Weight of evidence in Excel.
In Excel. Okay, the second question is, by the way, is this your graduation project or any sort of project that you do at your department? Is this your graduation project?
Yes.
Okay, so the participants recommended to apply also other prediction algorithms and machine learning algorithms, because you only used random forest for predicting the weights around the area, but they also recommend to use support vector machines, multi-layer perceptors, and other deep learning methods in order to make comparisons between the accuracies generated by all artificial intelligence algorithms. As I stated also the previous presenter, the participator would like to ask these questions. So as a recommendation, let's say, they try to encourage you to utilize other prediction algorithms in RStudio or Python. So do you have any response about that?
I don't understand. My English is beginner.
Okay, I will say rastgele orman dışında diğer tahmin algoritmalarının da kullanılmasını, yani çok katmanlı derin öğrenme yöntemleri ya da destek vektör makineleri gibi yöntemlerin de kullanılmasını öneriyor diğer araştırmacı arkadaşlarımız.
Evet.
Öyle söyleyebilirim. Thank you so much.
Teşekkür ederim.
The next presentation is going to be held by Mr. Müslüm Hacar on the status of wheelchair-tagged OpenStreetMap point data in European capital cities. Mr. Bashar, could you unshare your presentation screen? Mr. Hajar, you can drag to share your screen without waiting.
Okay.
I opened up the priority. Yes.
Yes, hello everyone. My name is Müslüm Hacar. This presentation is about the current status of wheelchair-tagged OpenStreetMap POIs in European capital cities.
Mr. Hajar, can you make your presentation on full screen, please, in order to see better?
It is actually full screen in my computer, but
no, it's
let me share again.
Yeah, please. Most of the laptops are small screens, so therefore sometimes the participants cannot read the lines.
Can you see it now?
Can you press F5, just F5? Yeah, now it's okay. Yeah, you can continue.
Okay.
Have a nice presentation. Thank you.
Okay, thank you. You can see our research interests here. This presentation consists of these subtitles. Let's start with the research problem. Accessing the information on wheelchair-friendly infrastructure quickly and accurately is crucial for a person with walking disability. Some volunteers enrich OpenStreetMap data with a wheelchair tag that provides information, whether a street building or any feature in OpenStreetMap is suitable or not for wheelchair use. However, since the tagged data is insufficient in many urban areas, OpenStreetMap data still requires some contributions. This study examines OpenStreetMap point of interest data in Ankara, comparing with 5 capital cities in Europe in terms of the statistics of the wheelchair tag contributions. A tag can be defined as a key and its exact value. Tags are the attributes of OpenStreetMap objects. There is no limit for the generation of OpenStreetMap tags, but there is high consensus on the most used tags. For example, there are also various tags for wheelchairs like wheelchairs, wheelchair friendly, and also the words in native language of volunteers. But the most preferred one by volunteers is wheelchair. The tag is presents whether feature is wheelchair friendly or not. This study focused on the statistic of both wheelchair tag and its values, yes, no, limited, and other values. Here you can see on the right figure the schema of the evaluation. Here, after the tags contributed most to the wheelchair tag points are called popular tags. The tag contributions are assessed from the popular tags used in wheelchair tag points to the wheelchair tag values. The study area consists of 6 capital cities. From the east to the west, they are Ankara, Sofia, Warsaw, Berlin, Paris, and London. You can see on the right the POI data, the density of the POIs in each capital cities. The study was conducted with only OpenStreetMap POIs in the respecting cities. The statistics of data given in table below shows that there is no correlation between the urban characteristics like population, total area of the buildings, and the number of points of interest. In other words, we can expect more point of interest data in Ankara because its population is higher than Sofia and Warsaw and Berlin. So it is relatively low. So the statistic results of the study, we can say that 4 popular tags in POIs contributed with wheelchair tags are name, amenity, shop, and building. The stack bar below in the figure represents the sum of wheelchair tags used in the POIs in the regarding cities. The green bar represents if the, for example, let's say name tag in Ankara. If the name tag exists, the wheelchair tag POIs, it's represented by green, and if not, it is represented by red bar. The stacked bar also represents the sum of wheelchair tags. So we can say that there is dramatic differences in the number of the used tags among the cities. For example, in Paris, approximately 37,000 of POIs. But if we compare with the Ankara, there is only 65 POIs for the wheelchair tag. But most of the wheelchair tag POIs have name tag. This is a statistical result. And also at least 36% of these POIs have the amenity tag, while over 10% of these POIs have shop tag. Less than 0.5% of them have the building tag. The distribution trends of the popular keys are similar in all cities. The trends from the most used tags by contributors to the least is observed as the name, amenity, shop, and building tags respectively. Also, we can say something about the distribution of wheelchair tag POIs in all POIs. You can see on the left the graph, if wheelchair tag POIs exist, it is represented by yellow bar, and if not, it is represented by blue bar. So wheelchair tag was used on a small number of POIs in each city, comparing with the number of all POIs. the tag was used the most in Paris and Berlin, which also have the greatest number of point of interest data. Sofia has 12 times less points than London, but it is more complete than London in terms of the well-shared tag rate in point of interest data. The tag was used the least in Ankara and Warsaw. The volunteers, we can say that the volunteers' interest in contributing information about well-shared suitability were the less in Ankara and Warsaw. And also we can say something about the percentage distribution of the well-shared tag values, that if the tag value is yes, it is represented by green, and if it is no, it is represented in the graph by red, and if limited, it is represented by orange, and for the others, it is gray bar. The suitability values of well-shared tags are represented as you see the yes value, no value, limited, and the others. Yes value is approximately half of all values in Berlin and Paris, and it was used the most in Warsaw and London. No value is more than 30% of well-shared tags in Paris, Sofia, Ankara, and Berlin, and also it was used the least in London and Warsaw. So we can say that the contributors focused on not only the well-shared friendly entities, but also unsuitable and restricted available entities in Ankara, Berlin, Paris, and Sofia. However, it seems that the interest of volunteers was mostly in well-shared friendly entities in Warsaw and London. Volunteers contributed to the most popular tags with the same trend in all cities. The trend from the most used to the least was occurred in the order as the name, amenity, shop, and building tags respectively. Paris and Berlin, which has the largest numbers of point of interest data, also the cities where the well-shared tag is used the most. Considering the population and urbanization of the case cities, it is expected that Ankara would have much more POIs and also well-shared tagged POIs than it currently has. Ankara has the least number of POIs compared with other capitals. Also, the city ranks second from the last after Warsaw in terms of the percentage of well-shared tagged POIs in all POIs. So it can be said that the volunteers' interest in contributing information about well-shared suitability were the less in Ankara and Warsaw. Thank you for listening to this presentation.
Thank you so much, Dr. Hajar. Actually, I would like to congratulate you to keen on open data and volunteer GIS. But first of all, I need to remind all participants that the presentations, PowerPoint presentations with animations can be get forward very slowly during the sharing the screen. So in the next time, please reduce the usage of animation between the slides, because sometimes it takes 10 seconds to see the complete screen. On the other hand, is this the final version of your work, or will you improve your content?
Actually, we are also working on some gamification challenges to improve the well-shared tagged POIs in Ankara, but it's in the beginning of the work. So yeah, it's a kind of ongoing project. Yeah.
There is a study group who is very interested in OpenStreetMap, actually open data services, and volunteer GIS in Polytechnic University of Milan, Italy. Professor Brovelli, who is one of our member of the scientific committee, her team is really interested in these kind of topics. You can get in touch with her in order to make cooperations for these issues. I recommend such a thing, but I think that this version is ready for publication. So I recommend your work to be published in one of our journals, maybe in Turkish or English, whatever you choose. But this is I think, a finalized matter of fact, let's say. So,
thank you so much.
About that?
Thank you so much for your advice to contact with the others researchers, and also thank you for others.
Okay, so I think the final presenter is absent, even though I texted him. He is not absent, but let's ask again. Mr. Kaka Apta or Abdulmajid Bukhari or Lukman Jiba. Are they, one of them is here from Nigeria. No. And on the next time, please, all the participants, especially the presenters, please add your surnames in your Zoom accounts. It is so difficult for us to choose who is the presenter without seeing your full name. All right. So since the presenters of the last paper are absent right now, I would like to conclude all the session. Thank you so much for your participation, and the next session will start 25 minutes later. Thank you. Good afternoon, ladies and gentlemen, dear scholars. We are starting in 2 minutes. The next session is on land administration, cadastre, and land use. We have 8 presentations registered for this session. 5 of the participants are already here. Let me check whether the rest of them are here or not. Okay, anyway, we can start with the first presentation from Istanbul Technical University, which will be presented by Mr. Mehmet İşler. The talk is legal aspects of space activities in international context. So, if Mr. İşler can hear me.
Yes, I can hear you.
Okay.
Can you hear me?
Yes,
clearly?
Yes,
okay.
yes, we can hear you clearly. And please share the presentation with us and introduce yourself in the beginning. Thank you so much.
Thank you. Thank you. Can you see my presentation?
Yes, we can, but it would be better if it's on full screen.
Yeah, okay. Now? Okay.
Yes, it's better, definitely. Thank you. Have a nice presentation.
Hello, everyone. My name is Mehmet İşler. I am a lecturer at Geometric Engineering Department at Istanbul Technical University. Today, I would like to present the legal aspect of space activities in international context briefly. As you can see, our presentation has 3 main parts. At first, in order to show the current international legal regime on the outer space, I'm going to mention about the basic 5 international law concerning space activities under the United Nations. Then, the role of the International Communication Union on allocation of satellites orbits will be mentioned. At last, I'm going to talk about our national space program that has been announced recently. What are the motivation of these studies? As you know that today, economic and social activities of humans on the land have been obviously increasing due to globalization trends and advances in technologies, of course. These rapid developments may cause housing, food, and the energy resources management as well. In this case, land should be managed with the sustainable development approach. The key of these effective and efficient management of these activities is qualified, correct, and up-to-date data. So, space-oriented technology enables to obtain land-related data, and it can provide many opportunities to manage land resources and human activities in local, regional, and global context. And also, you know that the mapping, urban rural planning, mining, and other related activities have become increasingly dependent on the data derived from space technology, such as Earth observation, communication, and navigation satellites. Our profession, geometric engineering, has played a key role in these organizations that perform many different services by using the space technology products, such as Earth observation and navigation satellites. And also, recently, our national space program has been announced, and this document states the vision, strategies, objectives, and project on space policies. These technical, legal, and administrative developments will affect our professional directly. Therefore, in addition to technical details, it is also important to understand the legal status of relevant studies. As you know that space law emerged as a result of the human effort to reach space. Space law is a sub-branch of the international law, and it regulates the studies and activities in outer space. Space law consists of international agreements under the United Nations and related documents supporting these agreements and other national laws and regulations. The main five agreements adopted under the United Nations can be summarized as Outer Space Treaty, Rescue Agreement, Liability Convention, Registration Convention, and Moon Agreement. Here, let's have a look at the timeline of the national legal arrangements about these 5 basic international agreements under the United Nations about outer space. It can be easily seen that the launch of Sputnik 1 is the milestone of the legal studies related to space. And Outer Space Treaty can be accepted as the basis legal documents, which includes main principle on international space law. Other 4 agreements that are listed in this timeline with their short titles, Rescue Agreement, Liability Convention, Registration Convention, and Moon Agreement, elaborate and reaffirm the provision of the Outer Space Treaty. Space law was formed in early years as a result of space race between USA and Soviet Union. These 5 international agreements were adopted between 1967 and 1979. And it's important that these agreements are listed in this timeline is still in force. In addition to these 5 agreements, we should mention about the principle adopted by the General Assembly. Main principles documents can be summarized as Declaration of Principles, Principles of Remote Sensing Satellites, Principles of Broadcasting, the Principles to the Use of Nuclear Power Resources in Outer Space, and Declaration of Benefits. Okay, we are talking about the space law. And what is the definition of outer space? Where is the outer space? Boundary of outer space is not described in this international law. While many countries define the Kármán line, which is 100 kilometers above the sea level, as the boundaries of the outer space, NASA defines the space limit to be about 80 kilometers above the sea level. Our country, Turkey, states that the definition and delimitation of space should be defined by joint work with International Civil Aviation Organization. Okay, let me tell about main topics on outer space territory and other agreements. According to the outer space territory, as you can see, the states are freedom to access the space, and space can be used for peaceful purposes only, and states cannot claim sovereignty over the moon and other celestial bodies. And all states parties are liable for any damage caused by their space objects. And states cannot place nuclear weapon or other weapon. Astronauts should be regarded as the envoy of mankind. Rescue Agreement elaborates the principle stated in Article 5 in Outer Space Treaty. Astronauts must be returned safely, and rescue agreement is to guarantee all possible steps to rescue and assist astronauts in case of accidents, emergencies, and compulsory landing that may occur during the space mission. Liability Convention establishes an effective rules for governing liability of the space objects. According to Article 2 in Liability Convention, a launching state shall be obviously liable to pay compensation for damage caused by its space object on the surface of the Earth or aircraft in the flight. The Registration Convention was adopted as a result of the Rescue Convention and Liability Convention. Each state shall provide the launching state, and it must be provide the identification number, and date and location of the launch, and basic orbital parameters. These information should be registered in the Secretary General of the United Nations as soon as practical. And the last one, the Moon Agreement, uses the expression of the common heritage of mankind for the Moon and its natural resources, and reaffirms that the Moon is not subject to the national appropriation. The Moon Agreement provides to establish an international regime which governs these natural resources of the Moon. Yes, there is a table that shows the status of the international agreements. Let's have a look. The total number of ratification and the signature is very low for Moon agreements because several space-capable countries are not a part of these agreements because there are several restrictions on using outer space resources. And Turkey has ratified these 5 basic international agreements regarding space activity, which are mentioned in this study. Yes, I want to talk about the International Communication Union, the role of the International Communication Union on the allocation of the satellite orbits. The International Telecommunication Union is the United Nations specialized agency for information and communication technology. It was founded in 1865 to facilitate international connectivity, communication networks, and allocation global radio spectrum and satellite orbits. It can be said that the geostationary orbit is subject to international authorization. A state planning to launch satellite in this orbit should apply to the International Communication Union, which is, and the country should launch its satellites according to the location given by ITU. At last, I would like to talk about our national space program. Our country has been working for a long time to take its place in space. The first step of the space activity for Turkey was launching of communication satellites. Then space development of Turkey have continued with the Earth monitoring and the reconnaissance satellites. For example, our first reconnaissance satellites, Göktürk-2, was launched in 2020, and also several cubic satellites projects have been completed. By the help of this development, the Turkish Space Agency was established as an affiliated part of the Ministry of Industry and Technology by Presidential Decree, and in 2018. Our country has started new studies in many areas, including regional satellite navigation and remote sensing system. Main objective of national space program can be summarized as developing space technologies in Turkey, reducing dependency on foreign resources related to space technologies, and increase the awareness of public on space. By the help of the mission that declared in national space program, economic and technological capacity can be increased extremely. Yes, we can move on the conclusion and suggestion part of my presentation. As you can see within the scope of this study, it's obviously seen that the international law concerning space activity is established as a result of the development of space studies. Year by year, space studies have become a significant global topic for all mankind. Today, many researchers have an opinion that some issues in international law concerning space activity should be discussed because the reasons capability of space-oriented works are increased. Space tourism, space mining is a new agent. Turkey is part of these 5 main international agreements that are mentioned in this study. Besides the technical efforts, national law regarding these activities should be prepared as soon as possible. In order to contribute and development of space industry, one of the main requirements is national law that regulates the priority issues related to space technology. These technical and legal improvements will support many public and private sectors, such as geographical information system and remote sensing industry. These industries are directly related to geometric engineering. So, in this case, our professionals should be a part of this process. Thank you for your attention.
Thank you so much, Mr. Işler, especially for emphasizing the key role of geomatics engineering in the conflict resolution, because we have resolved lots of land conflicts with our methods. So I hope that this sort of methods will be also eligible for the space race. Thank you so much for your contribution. And I checked whether there is any question related with the matter, but I think there is none. So thank you so much. The next presenter should be normally Mr. Nuri Erdem, but I cannot find his account here. So if he participates later, I will add him there. Then I need to skip to the other presenter, who is Esat Fikri Kılıç, on using artificial neural networks in land use, land change. Could you please share the screen with us?
Can you hear me?
Yes, we can hear you. Can you share your screen with us? Thank you.
My name is Esat Fikri Kılıç. I am a master student at Zonguldak University, Bülent Ecevit University. I want to start my presentation with your permission. The aim of this study is to detect and control the land cover distribution, change width, static shopping based on the satellite image of different times by using remote sensing techniques. My topic, using artificial neural networks in land use change. The content of my presentation consists of introduction method, results, and completion parts. Introductions with remote sensing techniques, it provides important opportunities to determine the changes in different scales and to be able to make comparative analysis through satellite images of different times in order to detect and control the change of land usage. The changes in land cover on land use increase the impact of environmental changes that lead to the change and transformation of the Earth. These changes and transformations depend on time. The reason for the change is the decision taken by local and regional governments in parallel with the economic, cultural, social, and ecological processes. Various statistical analysis and interpretation techniques are used to efficient Earth information from satellite images obtained in raw form. The most common method for converting data information is the classification of satellite images. In this study, Landsat 80 OLAY images from 2015 and 2020 were used in Çaycuma district of Zonguldak province. The QGIS program was used to determine the change of land usage. The following ways are briefly followed in the preprocessing of these images and obtaining a land use map. First, image processing, geometric and atmospheric correction was performed. The land classes to be used are designed. These classes are the forest area, water surface, structure, agriculture, bar land. Then test cities that could reveal the Earth characteristic in the image were determined and classified with appropriate algorithms. The controlled classification method was used in our study. Sample pixels were collected for each train's class road. The image before the classification was imitated. By analyzing the pixels values, the statistical characteristics of the classes were determined and the images were classified using the maximum likelihood method. In order to get used, artificial neural networks were used on land use change. The walls obtained by this method were compared with the maximum likelihood walls, and the speed and accuracy of the methods on creating classification were examined. And artificial neural networks model was created using MATLAB. The results compared with the walls obtained with maximum likelihood method and the usability of the methods in the field of land use change are shown. Controlled classification maps for 2015 and 2020 created with the QGIS program are given in the figures. Can you see? Data we obtained as a result of the controlled classification with maximum likelihood technique. Classification results for 2015 and 2020 are given in Table 1 and Table 2. Artificial neural networks in an often preferred method because it's successful in learning non-linear relationship by analyzing with samples. To start the application, the data must first be recognized and the network must be created after the input and output values are determined. The training phase of the network should be started. The model of artificial neural networks obtained by input and output values is given in figure. Learning status and that task graphs are given in figure. Find that and artificial neural networks model were created and then the values of the test results that were compared figure. Controlled classification and artificial neural networks output data for 2015 and 2020 are given in Table 3 and Table 4. In this study, Çaycuma district of Zonguldak province was examined with satellite images. For this purpose, Landsat 8 OLAY satellite images were used. In the working area, there are classes of forest areas, water surface, structure, agricultural land, bare lands. In order to distinguish these classes, controlled classification techniques were applied using satellite imagery. At the same time, it has been investigated whether there will be similar results with artificial neural networks. When the results were examined, it was seen that the data obtained by the maximum likelihood method and the data obtained by artificial neural networks are completely. The study based on this change of land usage using remote sensing technology is important for numerical analysis with the plans. In addition, the effective analysis of land features involved in planning and the ability to do it quickly and at low cost increase its availability. In this respect, it has been used more frequently in recent years. Artificial neural networks, which are now used in every application, have been shown to give accurate results in the studies. It should be noted that the number of data should be increased in order for artificial neural networks to give better results. Thank you for listening.
Thank you so much, Mr. Kılıç. Actually, we have one question from Kashyap from India. As you can see from the chat, he or she, I'm so sorry if he is a female one, he asks how weights were assigned in the artificial neural network model. And actually, I would like to ask the same question. Do you have any response for that?
Sorry, I don't understand you.
Do you see the chat part? how weights were assigned in the ANN model. Can you see the question?
Sorry, I don't see.
Okay, I will translate the response of him later. Yapay sinir ağ modelinde ağırlıkları nasıl belirlediğimizi soruyorlar.
Yapay sinir ağında MATLAB'la girdi ve çıktı değerlerimizle sonuç elde ediyoruz. Kontrollü sınıflandırma olarak. Kontrollü sınıflandırma ile karşılaştırdığımız zaman ortaya istediğimiz sonuçları elde ettik bu şekilde. Yapay sinir ağları ve uydu görüntülerinin bize verdiği sonuçlar.
Ağırlıklarla ilgili, yani biliyorsunuz ağırlıklar var ya, yapay sinir ağları oluşturulurken tek tek her bir epokta o ağırlıkların nasıl belirlendiğini soruyor katılımcı. Yani isterseniz sonra yazılı olarak da cevap verebilirsiniz. Şu an açıklayamıyorsanız.
Anlayamadım.
Sorunun karşılığını epoklardaki ağırlıkların nasıl belirlendiğini soruyorlar. Kontrollü, kontrolsüz fark ediyor.
Ağırlık kullanmadık biz.
Okay.
Ağırlık kullanmadık.
In the end, he responds that there is no weight selection in the process of ANN. This is the response. So I think there is no other question. Thank you so much. The next presentation will be conducted by, let's see, Fatma Betül Yıldız, generating historical cadastral parcels with artificial intelligence algorithms within the scope of Cadastre 2034. If she's ready and she can share her screen now. Thank you.
Dear colleagues, welcome to my presentation. My name is Fatma Betül Yıldız. The title of my presentation is Generating Sample Cadastral Parcels with Artificial Intelligence Algorithms within the scope of Cadastre 2034. My supervisors are İsmail Ercüment Ayazlı and Hidayet Takçı. The structure of presentation is first I introduce my topic and then I will give you a brief explanation about using methodology, and this presentation will contain with conclusion, introduction. This study aims to develop a new model in which the temporal dimension of cadastral parcels will be automatically digitized in accordance with the four-dimensional cadastral approach targeting the vision of Cadastre 2034. Then for an interface using artificial intelligence algorithms was created in the Python programming language and change in cadastral parcels can be monitored at the beginning from the first facility cadastre on any cadastral parcel. In Turkey, cadastral technical documents were scanned within the scope of the cadastral data consolidation project and converted into PDF. Our main goal is to extract temporal data of cadastral parcels from technical documents as fully as automatically using artificial intelligence algorithms. In this context, technical documents are automatically processed, which prepares software and temporal cadastral parcel data are generated according to data coordinate data. Conceptual framework benefits of discussed factor affecting the development in the cadastral fields such as globalization, urbanized population, good governance, climate change, environmental management, three-dimensional visualization, analysis technology, virus network standardization, and interoperability. In this context, the cadastre maintains the responsibility to reconstruct the infrastructure that will form the basic data from smart cities and GIS by a contemporary perspective. My methods are GUI design and image processing. General framework. Within the scope of this study, the PDF files of technical documents such as Fingerprinting, Spectral, application curricula are used for automatically digitizing. It can be seen here. At the beginning of the study, the PDF data are converted into an image format using the Python programming language. Interface has been created with button, start button, stop button, close button. PDF image, and their output. Then textual expressions and numerical data on the image were separated and saved in a separate file. The data were prepared using digital image processing methods as they contain noise. They were separated using noise cleans and adaptive threshold Gaussian methods. Interface and program continues to be developed. GUI design was carried out on Python 2D Designer. Functions were created on the design by importing it in Python with Py2t5. The image identification, the reading area, and the fields showing the separation of the characters are added to the design. The image was read with the read button and separation operations that can be done. Image processing techniques have been used as the extraction of the text of the image does not give an entry acceptable results when raw images are used directly. Some image processing steps applied to image can be listed as follows: removing remaining areas outside the text, finding and sharpening text by converting it to an AP with image, resizing the image, clearing unnecessary and non-texture expression on the text with adaptive thresholding methods as images are obtained in different areas and under different lighting conditions and Gaussian filter. One of the image filters then that can make the text more readable has been applied to soften the image. Python, Tesseract, and is deep learning text sensors, ocular, OC, Rufus, switch, OCR, LSTM technique used in text processing very frequent Python language. The best method has been determined. Python Tesseract used in the work is an optical character OCR Python for Python. Another tool used is deep learning text detector. These two tools offer the best techniques and settings for text recognition. Finally, conclusions. Since real estates are a reliable investment tool, the number of transactions carried out in the land registry and cadastral offices are increasing day by day. In the study, it was aimed to provide a more dynamic tracking system of cadastral records, and a solution was presented. According to results, it has been possible to digitize the data kept in different file formats automatically, regardless of the format, thanks to the development in computer technologies. The proposed solution was encoded in Python programming language, and the text were extracted and stored with artificial intelligence algorithms on the desktop application. In this way, the chain occurring from starting to first facility cadastre in the cadastral parser can be monitored graphically. Thanks for your attention.
Miss or Mrs. Yıldız, thank you so much for your presentation. We are waiting for the questions. Let's see. An anonymous attendee asks whether there is a GitHub repository for your codes or any platform.
There GitHub repo? No, no.
So do you consider to open up your codes publicly free?
Open source?
No, you close it. So it's hidden right now. Okay.
No, open source.
All right. Any other question? Let's check. There's another one. It's okay. Thank you so much. Before beginning the other presentations, there is a Ms. Yıldız, this is not related with your presentation. I'm talking in general. I would like to remind all the presenters related with machine learning approaches, because the participants sent a lot of questions related with hyperparameter tuning. Hyperparameter tuning is, in my opinion, a very important issue for machine learning approaches. And I agree with the participants who make these questions to the presenters. I recommend to all presenters who use artificial neural networks or machine learning and so on to introduce their hyperparameter tuning and other weights, scores, accuracy, and so on. Because otherwise the participants cannot understand the quality and the accuracy assessment of your work. So this is a recommendation for all those who use machine learning for their work. So thank you again, Ms. Yıldız, and the next presentation will be conducted by Mr. Mustafa Yılmaz on easement right valuation for electric power transmission lines. If he's ready and he can share his screen with us. Thank you. Mr. Yılmaz, could you unmute yourself? Could you open up your voice? Okay.
Can you hear me?
Yes, now we can hear you. Have a nice presentation. Thank you.
Thank you. Hi, everyone. My name is Mustafa Yılmaz. I have been working for Turkish electricity transmission company for 12 years, and I'm doing my master degree in Istanbul Technical University, Geomatic Engineering Department. The contents of the presentation is as seen on the screen. When expropriating electrical facilities, if there is a pylon place or substation, these areas are divided from the parcel and expropriated completely. Ownership passes to the institution. However, under power line wires, easement right is registered. In this case, the owners don't lose their properties. However, there will be some restriction on parcel usage. According to Turkish expropriation law, easement price is the decrease in value of the parcel because of this right. Eastman price is calculated by using this formula. In this formula, Ds is decrease coefficient, and decrease coefficient is examined in this study. According to Supreme Court decisions, decrease coefficient can be maximum 50% for zoning parcels. For agricultural parcels, it can be maximum 35%. However, most course experts generally accept decrease coefficient as 50%, but Eastman price must be determined according to factors affecting the decrease. If decrease coefficient is taken as maximum, the cost of the Eastman will be quite high. It causes a serious waste of public resources, a considerable increase of cost of energy investments, and unjustified enrichment of owners. In the study, first, factors affecting decrease rate and their base were determined. Then, scoring facts for each factor were determined. Finally, using binomial valuation method, decrease coefficient can be calculated by using this formula. Here, since scoring made over 10 points, so every point must be divided by 10. First factor affecting decrease rate is building area affected by energy transmission line. The weight of this factor is determined as 15%. For example, in figure 1A, 20% of the building is affected, so 3 points can be given. In figure 1B, more than 90% of the building is affected, so 10 points can be given. The second factor is possible building area. The weight of this factor is determined as 35%. In some cases, losses may occur in building areas. Some of the explanations about these cases have been given in our article. Scoring can be made according to the table. The third factor is the size of the parcel compared to the Eastman rate. The weight of this factor is determined as 10%. Although the amount of Eastman on both parcels is the same as in the example, different decrease rates will occur for each of them. For parcel A, since nearly 5% of the parcel is affected from the Eastman, 1 point can be given. For parcel B, nearly 50% of the parcel is affected, so 6 points should be given. The fourth factor is azimuth shape. The weight of this factor is determined as 25%. There are so many cases related to this factor. In this presentation, 6 cases will be examined. In parcel A, Eastman passes parallel to the road and covers a very small area of the parcel. Probably, this part will remain as a garden. As a result, the building will not be affected by the Eastman in any way, so 1 point can be given. In parcel B, nearly half of the parcel is affected by the Eastman. One of the areas outside the Eastman is triangular area and is not suitable for building. The other part is trapezoidal and suitable for building. However, the building will not be shaped properly, so 8 points can be given. In parcel C, Eastman affects the parcel to a very small extent. The remaining part of the parcel is trapezoidal it is possible to create a properly shaped building here. So 2 points can be allocated. In parcel D, Eastman affects per parcel nearly 50%. When a building is desired to be built outside the restricted easement area, a proper building can be formed, so 5 points can be given. When there is a pylon in the parcel, the pylon will be subdivided from the parcel, so the remaining parcel will not be shaped properly. In this case, there will be a decrease in value of the parcel, so 5 points are given for pylon place. The remaining 5 points can be given according to shape and percentage of the easement. In figure 4, the pylon is in a very large parcel. Easement doesn't affect the buildings, so 5 points for pylon place and 1 point for the easement can be given. The total score can be 6 points. However, after the pylon place is subdivided from the parcel, in the figure 5, there will be no area suitable for building. So, according to Turkish expropriation law, Article 12, the entire parcel should be expropriated. The last factor is psychological factors and health effects. The weight of this factor is determined as 15%. You see some of the effects of this factor on the screen, such as the radiation effects on human health, difficulties in getting loan or mortgage, and so on. Scoring can be done as follows. 5 points will be given as fixed for each parcel to be expropriated. The remaining 5 points can be given according to the table. A sample calculation has been made to see the effects of the model. First, the price by court experts was calculated. Here, decrease coefficient is taken as 50%. Then, the easement price was calculated with nominal valuation model. Decrease coefficient here is seen here. The values of the easement with different approaches are given in the table. When these data are compared, it can be seen that market value and nominal value are very close to each other. However, there is a huge difference between these two values and the court value. This causes financial loss of public resources. Furthermore, the owner of the parcel will also receive more than should be received. In this study, factors affecting decrease easement right price are examined and a valuation model is proposed. It is hoped that this study could provide a good guide in determination of easement prices and in studies of making law and regulations. Thank you for listening and your patience.
Thank you so much, Mr. Yilmaz. I haven't received any questions from the participants, either in Zoom and YouTube, so we can continue with the next presentation. Thank you again for your participation. The next presentation will be done by Mrs. İrem Yurday on the urban agriculture approach to evaluating urban-rural interfaces. You can share your screen directly with us without waiting further.
You can see?
Yes, we can see. But do you have any full screen option?
No.
Okay, this is a PDF. Okay.
Yes.
Okay, thank you so much and have a nice presentation. And please consider you have just 8 minutes, okay? We have
okay. Hello to everyone. My name is İrem Yurcay. I am master student in the Department of Geometric Engineering, Konya Technical University. We prepared this paper with my lecturer Fatih İşcan and Ceren Yağcı. My study topic is the urban agriculture approach to evaluation urban-rural interface. I want to start my presentation with a poem. There is a need to bring life into the city, so that its forest inhabitants will have not merely sun and air, but some change to touch and feel and cultivate the earth. Lewis Mumford. In this study, the definition and advantages of urban agriculture, as well as examples of urban agriculture plans and policy implemented by countries have been discussed. More than half of the world's population live in cities. As the urbanization rate increases, food production facilities should be located close to main consumption centers. As 2/3 of the world's population is estimated to concentrate in urban areas within 4 years, a durable food system will become more important for city developers. One of the suggested solutions to make cities more sustainable is to implement local urban farming system. In this way, urban agriculture will become increasingly important. Urban agriculture was described as an essential component of the growth of cities and their adjacent rural areas, with the potential of dramatically shorten food and ecosystem service supply chains in the face of rising urbanization. Urban agriculture provides food source in cities through new technology, increases in the resilience of food system, and ensure food security in urban areas. Dimension of urban agriculture. The benefits of urban agriculture are numerous and encompass the economic, social, environmental, reduction of air pollution, the rise of humidity, expand aesthetic and recreational areas associated with green space, aims to reduce food insecurity in cities. Social, city developers, a garden or rooftop farm is a place where they can come together for mutual benefit and also establish and connection, shared social and cultural identity, reduce stress in people and contribute to a healthier diet. Economical, it is effective in reducing the maintenance cost of public space, increasing local employment and income generating opportunities for the low income group levels of city. Legal background of urban agriculture. Many cities in developed countries have recognized benefits of urban agriculture and have developed planning and policy strategies to support food production. In almost all developing countries, urban agriculture lacks a legal foundation because its connection to the city has been overlooked as a result of rural life. There is also no legal legislation relevant to urban agriculture in Turkey, as there are only a few examples of the incorporation of urban agriculture and urban application, but peri-urban agriculture can be initiated through the enactment process. Many villages in Turkey's metropolitan cities have been merged into the city limits as a result of Law No. 6360. Agriculture and agricultural production will inevitably continue under the name of peri-urban agriculture activity. These new neighborhoods, which cannot be regarded as cities by only being including the city boundary. Suggestions were made to decision makers, metropolitan councils, in order to increase the potential benefits of the peri-urban agriculture by allowing agriculture on the interface that serve as a translation between urban and rural areas. To implement healthier urban and peri-urban agriculture in Turkey, in the process of urban agriculture land use, it should be included spatial plans, construction regulation. The General Director of Geographic Information System and General Director of Spatial Planning should work together to promote urban agriculture in metropolitan areas as soon as possible. For a better implementation of urban agriculture, legal criteria should be reviewed, and decision makers should develop an agriculture regulation. The outputs of urban agriculture should be reviewed, more attention should be paid to its benefits and disadvantages should be minimized. Urban farmers should be provided with training and professional technical assistance. Support should be provided in the production and processing stage, and the opportunity to sell their production in public places such as the coast canteens, markets, and associations should be offered. Providing landmine municipality to low-income groups in the city through renting and releasing production should be encouraged. Finally, agriculture and agricultural-based activities should be established in areas that have acquired urban status but have not yet been urbanization as a result of Law No. 6360. Thanks for listening.
Thank you for presenting, Ms. Yurday. By the way, I personally adore this topic. I like it so much because urban agriculture and urban gardening, let's say, urban greenhouses, there are lots of terms related with this topic. Especially in European countries, there are some specific gardens nearby the urban centers, let's say leisure gardens. And I would like to see these things also in our country. And I would like to encourage you to go on with this topic. And especially for the legislation proposal, you can write down some sort of legislation proposal with your supervisors, because this topic is valuable for leisure and agricultural productivity. I would like to congratulate you and thank you for pointing on the time. Thank you.
Thank you so much.
Do you have any questions from the participants? I think no. Okay, we can skip
okay,
the other.
see you.
The other presentation is from India. Rahul Kashyap on anthropogenic intrusions leading to variability in vegetated versus non-vegetated land dynamics over the past 2 decades in India. So, sir, if you are ready, please share the screen with us and have a nice presentation, and please stick to the time, 8 minutes. Thank you.
Sure, I'll try to. Can you see my screen now?
Yes, but it's better in...
Çok heyecanlandım. Konuşamadım ilk başta.
Can you see it?
Yes, we can see. Please go on. Thank you.
A very good evening to all. I am Rahul Kashyap. I am student of Integrated MTech in Geoinformatics at Central University of Jharkhand, and I am here to talk about anthropogenic intrusions, which is leading to variability in the vegetated and the non-vegetated land cover dynamics over the past 2 decades in the Indian subcontinent. As we all know, there has been a great deal of spatio-temporal variability in the land cover and land use in the past 2 decades. Various factors such as natural hazards, extremes which has led to, and in the changing in the climate has led to these variabilities. Also, the increasing demand for resources and the increasing human population also one of the major reasons for this kind of change. The land cover changes is very much connected to the global climate change, as the land cover changes induces changes in the global carbon cycle, which further leads to changes in the global climate. Scenarios of future anthropogenic land cover land use suggest that continued changes as a result of increasing demand of food and energy, which is directly proportional to the increasing population. And agriculture production may be a key indicator for food security and connection between crop yield and food security. The major concern of this study lies in examining the dynamics of vegetated land versus non-vegetated land as a result of anthropogenic activities in the past 2 decades using model-based satellite curve product. In this study, we have taken the Terra and Aqua combined MODIS MCD Q12Q1 version 6 product for the time interval of the year 2001 to 2019. The product Spring uses supervised classification, undergo additional post-processing, which incorporate the prior knowledge and ancillary information to further define specific classes. These classes were reclassified and they were merged together into 3 main classes like forest, cropland, and others, which were the rest of the classes. In order to detect the contribution of human-induced changes, the dynamics of the human settlement in terms of urbanized area at 3 focal points, that is the year 2001, 10, and 19 has been examined. The focal period analysis, decadal change, fractional land cover change, overall change, and change in the decadal trend in forest, cropland, urban, and rest of the areas analyzed. As you can see in this figure, the focal period analysis basically at the year 2001, 10, and 19. This bars you can see the forest, cropland, and others. These are the percentage. In 2001, forest is estimated to cover 8.46 of the land, cropland at 58.09, urban at 1.04. Or it can be said that 66.55% is vegetated area, 33.45 is non-vegetated. In year 2010, this dynamic slightly changes to 8.84% of land is cropland, forest, 59.59 is cropland. Overall, it can be said that 68.39 is vegetated and 31.06 is non-vegetated. In 2009, the forest cover increased to 9.26, cropland also increased to 60.56. Overall, 69.89 is vegetated and 30.16 is non-vegetated. This is the decadal change. From 2001 to 2010, the first decade, and 2010 to 2019, the second decade, the forest cover has increased at the rate of 0.41% per year. Cropland records a lower increase at 0.25% per year. Urban accounts for 0.18% per year. Overall, the vegetated area has increased at the rate of 0.33% per year, while the non-vegetated area has decreased at the rate of 0.55% per year. While in the other decade, that is 2010 to 19, the forest cover has increased at a better rate at 0.52% per year. Cropland records a lower increase at 0.16% per year. The over-vegetated area has increased at 0.34% per year, and the non-vegetated area has decreased at 0.45% per year. This is the 2001 and 2019, the forest, cropland, others map. You can see the changes in some patches, especially in Northeast and all. This is separately, forest, cropland separately. The forest cover significantly increased at 9.52% at the rate of 0.5% over the entire time span of the 2 decades. Cropland at 4.24% at the rate of 0.22%. Urban growth at 6.35% overall at the rate of 0.33% per year. The vegetated area has increased past 6.88% at the rate of 0.36% per year, while the non-vegetated land has decreased by 9.8% at the rate of 0.51% per year. This is the percentage change in context of the Indian landmass of the 2 decades. Forest cover has increased by 0.34% at the rate of 0.03, cropland at 1.49, urban at 0.016. Overall, the vegetated fraction cover has increased by 0.915%, and the non-vegetated has decreased by 1.84% in the first decade, while in the second decade, the forest cover has increased by 0.45, the cropland at 0.97%, the overall vegetated has increased by a fraction of 0.71%, and the others, that is non-vegetated, has decreased by 1.43. This is the change in the decadal trend, that is difference of both the decades, the positive and negative. The forest cover is showing positive at 0.34, cropland at higher positive at 1.49. Urban also shows small positive. In the next decade, forest cover has increased at a better rate at 0.45. Cropland also has a better rate at 0.97. Urban also has a better rate at 0.44. This is decadal increase in vegetated and non-vegetated land. The green patches shows the increase in the vegetated land, and the red patches shows the increase in the non-vegetated land area. And the rest of the gray area does not show any significant change. Overall, the forest cover is increased by 1.1%, while the cropland increase is decreased by 0.94. The increase in the urban expansion is increased by 0.267%. Overall, the vegetated land has increased by 0.08 and non-vegetated land is decreased by 0.97. Forest cover has gradually been increasing over the decades. Talking about the conclusions, that 0.46 to 8.8 to 9.26 in 2019. Cropland similarly at 58.09 in 2001 to 59.5 in 2010, 60.56 2019. Overall vegetated land has also been increasing over the years. Forest cover also increasing at a rate of 0.5%. Cropland at the rate of 4.24%. That is to say, the cropland is increasing at a better rate than the forest. Overall vegetated land is increasing at 6.88. The difference in the decadal trend showed as the forest cover increased by 1.1%. The increase in the urban expansion is also increasing by 2.67% every year. There's a greater rate of growth in the urban areas, while you can see the vegetated land is increasing at a 0.08, while the urban is increasing at a 2.67. There's a greater growth in the urban area owing to the greater population demand. At the same time, a smaller growth in the vegetated areas is seen over the Indian landmass over the past 2 decades. The population load, as we all know, requires resources to survive, and these resources comes at the cost of slower growth in the vegetated area. In order to meet the UN Sustainable Development Goal, the vegetated area should be growing at a faster rate than the urban area, but this seems unlikely, seeing the population growth in the recent decades. These are some of the references used for the study. I'm Rahul Kashyap. Very hearty sense of acknowledgement to IDG Turkey. Thanks a lot.
Thank you so much, Mr. Kashyap. Actually, I have a small question. In your analysis, the forest rates are increasing in India, even though most of the countries suffer from deforestation, especially for timber production, human activities, and agricultural activities. What is the reason for this forestation in India? Is there any land policy in India conducted by the government or any other environmental reason for that?
Not exactly sure of the reasons. This might be in some areas in northeast and some of the in the southern area. There are certain things like forest cultivation has regenerated. Like in some of the areas, they are regenerating for the forest, especially in the areas which are far from the cities, near the Western Ghats and all. In the western side, in the northeast also, they are doing this sort of practices. I'm not very sure, to be honest, of the exact reasons. This is based on modest products, which is not very accurate, to be very honest, but still this is.
In order to support our quantitative results, maybe it would be better to integrate qualitative results with it, because this is a very significant result of your analysis. Forestation in a country where can be a climate change response or any deforestation activities may occur. But there's a significant forestation in India, according to your results. Thank you so much for your presentation. And I'm checking whether there is another question from the other participants. No, we don't have. So we can skip to the other presentation. Thank you again. The other one is Seda Gamze Hamal, usability of wearable mobile laser systems in cadastral studies. Actually, we were unsure about putting which session should be this presentation in. But since the theme is cadastral studies, we decided to put it in the land administration session, even though it contains a lot of photogrammetry inside. So it's a very cutting edge topic, so enjoy. Thank you.
Thank you.
Can you share the presentation with us?
Mm-hmm. Can you hear me?
Yes, we can hear you and we can see your presentation. Please go on. Thank you.
Okay, can I start? Good afternoon, everyone. Let me introduce myself. My name is Seda, and I am continuing my education in remote sensing and GIS from the Mersin University. Today, I would like to talk to you about usability of variable mobile laser system in cadastral studies. My presentation will take about 8 minutes. My presentation is in 5 parts. I would like to start with introduction to the area. Following that, I will show material and method, data processing, and finally we will look at result. Social and environmental development have gained a new dimension with the differentiation of human-soil relationship and land use. Cadastre 2014 and Cadastre 2034 discussion began with the vision of sustainable land management for the next 20 years. In this direction, sensitive, current, object-oriented, 3D and 4D cadastral concepts have been the primary goals. It is known that 99% of cadastral works in Turkey have been completed. However, the methods used and the equipment accepted from the precision expected from the cadastre are insufficient, making some incorrect or incomplete measurement finding solution to existing problems such as digitizing existing cadastral data and international standards adopted by Turkey. LIDM inspired Cadastre 2014 and beyond creates the need for cadastral renewal. These studies can be carried out with the technical development as well as traditional measurement method, allowing them to be made with new method and equipment. Mersin University Çiftliköy campus has been selected as the Faculty of Engineering test area. Operation were carried out with the VMLS device in an area of 18,660 square meters. The field's works was completed in 2 sessions and 40 minutes. In this study, the usability of laser scanning technology in renovation cadastral activities was examined. In this study, VMLS total station and GNSS receiver were used to measure reference points. In addition, the orthophoto obtained from the study area with the UAV photogrammetry was used in an integrated way. The VMLS scanner is a measuring device with an IMU integrated position system without the need for the time of flight satellite navigation systems. All the details surrounding the scanner are determined by the niche location and mapping algorithm. VMLS extracted a 3D point cloud of the area by detecting different geometric properties of the surrounding objects. The map of the working area can be created in the local coordinate system. Voludyne sensor incorporate features such as real-time measurements, 360 degrees field of view, 3D distance, and calibrated reflection measurement in LiDAR technology. Data processing part consists of 2 parts. The first part is the process of creating an adjustment point cloud. The second part is the process of georeferencing and creating 2D orthophotos. In order to process the data obtained from field scans, the process was performed in Heron desktop software. In the process phase, the necessary odometer settings were made first. The odometer process step is given in the feature. In the cloud filtering part of the first section, minimum distance and maximum distance settings. It is the section where it is adjusted to eliminate distortion that will occur according to the structure of the land, the location of the objects, and environmental factors. In the second chapter, local map setting determined to geometrical critical of the 3D point cloud map to be created. The third part is the registration part. In the laser scanning process, scans are carried or overlapped. In the registration section, the transformation parameters between 2 point cloud are calculated with points in the common scanning area. Therefore, correspondence and ICP iteration are important to reduce to minimum error and obtain a precise result. The create map process is the process of creating an index map by splitting it into projector map clusters. This process is done to align to separate map clusters and to produce more precise 3D models. Also, Harris deductor algorithm has been chosen to detect corner of the structure in the study area. After creating map, it is passed to the global optimization section. The ICP iteration number is chosen as default in the parameter adjustment with the alignment of the fragmented maps. The main purpose of this section is to increase the precision of accuracy. After parameter setting, linked to fragmented maps are tied and connected to each other. While connected to two maps here, overland and RMSD values have been paid attention to. All fragment maps have been connected in accordance with this condition and adjustment by selecting the optimized clusters. Point cloud data is transferred to the reconstructor software for the last step of georeferencing. During the field area, references point survey were made in the area where GCP was measured by GNSS and total station device. By using these target points, the transformation from local coordinate to real world coordinate has been realized in the software. The average error after conversion is 3 centimeters. 2D orthophoto image was obtained by using the point cloud data created in the software. These orthophoto and orthophoto image produced with UAV were drawn in the Netcast software and comparison were made. As a result of the vector drawings made on both orthophotos, these data were compared in terms of accuracy. First drawings were made from the image produced from LiDAR, and then drawings were made on the image obtained from the UAV. For the accuracy of these drawing measurements were carried out at the location determined by ground measurement techniques during the field study phase. The same range were taken from both orthophotos and compared with the spatial measurement data. It has been observed that moving objects in the environment have a negative effect on scans due to outdoor measurements. For this region, it has been determined that there should not be any moving object close to the device during the measurement. As seen in the feature on the right, it is possible to see all of the external stairs, balconies of the building in the VMLS 3D point cloud. As seen in the feature of the left, it has been observed that with VMLS, smooth geometric structure with sharp boundaries are modeled very well. And when the driving process are made in parallel with the point cloud, healthier driving can be obtained from orthophoto produce. The most difficult areas in driving made from orthophoto produce with UAV were wooded areas. The fact that the information about the field under the tree is empty did not allow driving. As can be seen in the clouds produced, especially in wooded areas of VMLS, the pavement corner under the tree and the road borders are clearly visible. VMLS, there are advantages and disadvantages of having all the details struck by the laser of the scanned area to the orthophotos. The disadvantage of the data obtained by VMLS in the process is that the parameter values vary according to field and scanning, and it depends on the experience of the operator. While driving with the VMLS orthophoto, going parallel with the point cloud provides a healthy driving opportunity. In the 2D image, it is possible to see all the identification and access of the buildings such as balconies and porches. In addition, it was determined that the borderline in the area where the trees are located are seen more clearly in 2D orthophotos. Therefore, it is suggested that the VMLS device can be used in cadastral renewable works. Thank you very much for attention. That brings to me end of my presentation. I hope you are a little clear on my presentation.
Thank you so much for the presentation. I'm expecting questions, but there is none, so we can skip to the other. But normally we need to conclude the session, but we have an extra one from the previous session. She is excusing us for time differences between her country and Turkey. So therefore we need to accept her for a short presentation. So Lady Kaka Atta, are you here?
I can't hear, please.
Seda, we finished with you.
Thank you. Thank you. Thank you.
Lady Kakata, are you there? We are giving you the second chance to present your work. Are you there? Actually, I reminded her to be in front of the computer when I called her name, but again, she is absent again, even though she was here. Let me check. No, she's not here. So I need to conclude the session. Thank you so much for the participation to land administration session. So we will start again at 16:15 for the next photogrammetry and remote sensing session. Thank you so much. Gentle participants, welcome back again for the final session of today. The last session is entitled as Photogrammetry and Remote Sensing 2. There are 6 presentations scheduled in this session, but one presentation will be also conducted, which couldn't be presented in the morning. And the presenters, I think they are ready. The first presentation will be conducted by Güray Hatipoğlu. Are you here?
Yes, I am here. Hello.
Hello. His presentation's title is Checking Landsat 8 OLI's Predictive Power in the Retrieval of Chlorophyll A and, this is very difficult for me, phycocyanin concentrations of a reservoir with high-frequency field data. If you are ready, please share the screen with us. Thank you.
I am ready. I am sharing my screen. Can you see it?
Yes, but it's better if it's full screen. Yeah, perfect. Have a nice presentation. Thank you.
Okay. Hello again. I am Güray Hatipoğlu. I am a PhD candidate in Middle East Technical University's Earth System Science Department. I am working on water quality variables retrieval, especially inland water bodies, but via remote sensing means. Since it's very costly and labor intensive to retrieve water quality via directly going to the various environments and obtaining them. In this case, I'm focusing on chlorophyll A and phycocyanin concentrations. They are important because they are significant indicators of eutrophication, harmful algal blooms, especially causing from cyanobacteria for phycocyanin case, and you can also estimate ecological dynamics via retrieving them from satellites. But in their retrieval, there are of course some problems, like people generally focus on certain study area and generate a linear regression or some power equations regulations with their available field data, make some calibration and validation, but they only but this equation is only confined in that specific area. You can't just directly take them, apply them to other water bodies, because many affected optical properties actually unique to, not unique, but different in different bodies. So some other approaches also required. Some people tried to generate a global algorithms using many hundreds of different lakes or rivers to have an equation that can estimate chlorophyll or phycocyanin variables from everywhere, but they have some variable accuracy, and you can't actually be sure that if I apply this global algorithm directly in a certain lake, would it be successful or not? Even though you can apply it to 100 places and you get an overall good accuracy. And another thing is, while they apply these, try to generate these algorithms, they need to have field sample and satellites overpass at least near times, but there are generally 1 or 2 days lag. So that means a lot actually, since you can see, for instance, 7-hour time difference here, which each grid means 10-minute differences in chlorophyll at blue line and phycocyanin at gray line. So if you grab your sample in, for instance, at 21 here, and satellite will be passed here at 25, which is actually a less than 1 hour difference, you might have almost twice different concentration. And as you might guess, it's quite important, especially in low concentration of chlorophyll A, where this is the case in certain places and mostly here. And this is another example to the very short time scale variable of the chlorophyll A and phycocyanin here. So the idea is that you need to generate your algorithms to retrieve chlorophyll A via satellite remote sensing with very high frequency data, so that your satellite overpass and field sampling should be almost simultaneous. In this data, for instance, there's a 10 minutes difference between two sampling. So at most, you will have 5-minute difference between satellite overpass and your sampling in situ. So you would probably know the exact value of the chlorophyll area when you try to estimate it from the satellite. So in order to realize this and to check the some of the current available algorithms that can be used with Landsat 8 in inland waters, I retrieved field data of Carey et al. From 2021 in Virginia, United States, where you can use the data after proper citation from Environmental Data Initiative repository. And I choose Landsat 8 because Landsat 8 has enough spatial resolution of 30 by 30 meters that can be used in inland waters. And I choose top of atmosphere reflectance because different types of atmospheric corrections with different atmospheric correction parameters affects the outcome of chlorophyll retrieval as well. So whether or not checking the power of the algorithms will be also dependent on the atmospheric correction if you use surface reflectance values. So I chose to compare them with top of atmosphere reflectance in this case. I retrieved all the data from Google Earth Engine. So this is the exact place of the reservoir I'm talking about, which I also show you the sample in situ data in these two tables as well. It's quite undisturbed place. It's between a forested area. And these at the right table, you see the sample algorithms, which most of them actually being used in terrestrial chlorophyll retrieval, but they're also useful in water aquatic chlorophyll retrieval as well, since they have similar reflectance. Chlorophyll itself has the same reflectance, but their medium might change some things, which still doesn't undermine the effort much. So if I come to the results, first, I want to show you the Landsat 8's operational length imagers bands correlation between each other. This means that when you try to establish an algorithm like these people constructed before, if you try to use band 1 and band 2 together, it's meaningless because they are already very correlated with each other. But band 1 and band 5, or band 4 and band 5, for instance, quite useful since they carry different information from the fields. So you can combine them and you might as well get satisfactory results. In this case, band 4 corresponds to the red and band 5 corresponds to the near IR. So they are quite important in retrieving chlorophyll, especially in turbid waters and inland waters maybe. When I tried to obtain chlorophyll via these algorithms, however, it was unsuccessful. So I didn't directly report them here, but for phycocyanin, which is related to the cyanobacteria, and that is important for the harmful algal bloom prediction, they are actually quite significant, even though the correlations are negative, which means that the algorithms here try to estimate something, and their estimation is almost inversely related with the cyanobacteria, which is a curious result because cyanobacteria also carry chlorophyll and other green algorithms as well. And I also checked the correlation of these simple algorithms with phycocyanin to chlorophyll ratio, which might still give you some information regarding chlorophyll, phytoplankton and chlorophyll abundance again. And one algorithm is actually looks quite promising. But as a matter of fact, I just managed to have 9 total sample satellite overpass and field overpass directly. Their number is quite low, so it is really hard to make a calibration validation or some other linear equation. So this might really be approached as an exploratory design. And rather like a test of these already available algorithms, whether they are robust enough to be applied in a directly new situation, which is mostly not the case, and especially most not the case for the chlorophyll directly. So as a result, I also wanted to discuss that the concentrations of the chlorophyll and phycocyanin in this study area are quite low, which might induce the success of the algorithms to retrieve them, because when it is really low, it is really hard to see from the satellite as well. Even though in coastal regions, some algorithms can quite very well estimate the low concentration. In inland waters, those algorithms generally don't work very well. And with growing amount of available data, with more amount of satellite and field data matchups, different analysis should be conducted. And a chlorophyll retrieval should also be solved as well. And one other thing is these phycocyanin and chlorophyll retrievals are at the end, they're just indicator variables. The change of their directly change that might be induced by many things like sunlight, cloudiness, temperature, nutrients in the lakes, etc., etc. So if we have directly number of the phytoplankton or cyanobacteria counts, we can try to estimate them from the satellite, and that might be more easier. That might be easier. So this is the end of my presentation. I can take your questions right now.
Thank you so much, Mr. Hatipoğlu, and I would like to congratulate you about your comparisons related with the bands of Landsat 8. So actually, we are waiting for the questions from the audience, but let me check the YouTube. It's okay, there's none. So we can skip to the other presenter, who is Samane Bagheri. Are you here? Bagheri is here, Samane Bagheri. He's the corresponding author of the following presentation.
Yes, I'm here.
Okay, so she's going to present us the investigation and modeling of physical growth of urban areas using nighttime light data. If you're ready, you can share your screen with us. Okay. And you have 8 minutes. Thank you.
Okay. Okay. In the name of God, hello everybody. My name is Samane Bagheri. I'm master student RS and GIS from Uni Tabriz.
Sorry for interruption. Can you make the presentation on full screen? It is better to follow up. By pressing F5 or that.
Okay.
Oh, yes, exactly.
Okay.
Thank you. Have a nice presentation.
In the name of God, hello everybody. My name is Samane Bagheri. I'm master student RS and GIS from Uni Tabriz, Iran. Thank you for inviting to the conference. My topic is investigation and modeling of physical growth of urban areas using nighttime light data. The process of urbanization and urban growth in different parts of the world is the result of interwide interaction between various social, economic, political, technological, geographical, and cultural factors. Recently, development of quantitative urbanism and our increasing ability to collect and share data on many aspects of urban life have begun to supply us with better clues to the properties of cities. In this regard, the role of remote sensing techniques and data in identifying change and population growth has been brighter than other methods. Nighttime light observation from remote sensing provide us with a timely and especially explicit measure of human activities. In this study, we present a new multi-stage approach that demonstrates that we would like to evaluate the efficiency of nighttime light measurement in understanding the extent of urban boundary change and its development over a 9-year period. The purpose of this study in the present the application of satellite remote sensing to determine the causes of change and various factors affecting the development and increasing of urban areas and comparisons between several locations. These are samples of nighttime light image for the cities of Tehran and Tabriz for 2020. Material and methods. In this study, the experimental framework for measuring urban growth consists of 3 stages: land cover production, nightlight classification, and drive time calculation. Each of these steps has its own processing. Each of these datasets has advantages and disadvantages. If logically combined, the 3 datasets can provide a more accurate estimate of the city's physical growth. The algorithm used in this study is called the Bantus algorithm, built-in nightlight and drive time for urban sites. In the following, we will show the study area and explain each step separately, and we will examine their combination and the final result. Case studies. In this pilot study, we chose 2 cities that test different aspects of Bantus. These study cities are the metropolises of Iran, Tehran and Tabriz. Method. Land cover mapping. For the land cover mapping, Landsat ETM and Landsat OLI's product have been used. ETM images were used to produce the ground cover map for 2012, and Landsat 8 images for the rest of the year. First, the necessary processing, such as radiometric and atmospheric correction, were performed in MV image survey software. Then, the images were classified using the SVM method. At first, each image was classified into 4 classes, and then we divided those 4 classes into 2 classes to identify the built-in and non-created areas. In selecting the training data, Google Earth was used to help classify it correctly. An error matrix was used to evaluate the accuracy of land cover produced through classification. The results showed that the accuracy of the 4 classified classes was between 85% and 90%. We divided the 4 classes into 2 classes, built-in and unbuilt. The construct was assigned a value of 1, and everything else was assigned a non-constructed value of 0. Since our main focus was area construction, reclassification was more than 90% successful in all datasets. Finally, focal statistic analysis was performed on the 2-class image in ArcGIS software, and it was ready to be collected with other data. Nighttime light data processing. Nighttime light satellite image are a class of remote sensing product globally available for multiple years. In this research, we use VIRS image and various strategies to find the DN threshold for urban areas. For multivariate analysis, we categorize nighttime light image into 5 classes to establish the relationship between DN and ground cover. We categorize the VIRS dataset into 5 classes at their native resolution of 742 meters. Using this threshold, we classified VIRS data into 2 classes. Travel distance raster creation. To do this, a travel time layer was generated in QGIS software using the ROI platform. This tool calculated travel time without any restriction, such as traffic, and based on the intended speed in each route. Eventually, it became a raster in ArcGIS software. Fusion of dataset. Once the raster were produced, we processed to merge those rasters. A simple sum of the raster was generated according to the following formula. DN out equal DN built plus DN nighttime light plus DN travel time. Finally, we divided the generated layer into 2 classes according to the logical threshold. We selected the largest adjacent urban area, which included the urban core, and turned it into a vector polygon of data. Result fusion and fusion of dataset for Tehran and Tabriz. In the figure below, you can see the amount of change in the urban border in the cities of Tehran and Tabriz. The results show that the growth has a generous slope in both cities. The chart related to urban area change from 2012 to 2020 also show the slow growth of the urban border in the studied cities. Discussion and conclusion. For this study, we sought an algorithm that is robust, consistent, and efficient enough to define the trend of global urban dispersion for many cities over decades. Due to the quality and availability of data variables and fully automated and public algorithms. This method allows to achieve the growth of the urban border of all cities with it. The result of this study showed that the metropolises of Tehran and Tabriz in this 9-year period have not experienced significant physical growth and have only a small growth that has occurred in different areas of the city. The area of Tehran metropolises in this 9-year period has increased by about 66 square kilometers, and the city of Tabriz has increased by about 5 square kilometers. Thank you so much.
Thank you so much, too, Ms. Bagheri. Actually, 66 square kilometers in 9 years for Tehran, right? Very huge number, 66 kilometers square.
Yes.
Actually, this topic is very interesting because monitoring the physical growth is generally conducted by land use and land cover change with the traditional remote sensing methods. But I would like to recommend you something. You can also use this night data in order to predict the future urban growth, in order to simulate the future urban growth with some techniques, urban growth simulation prediction models. It can be very valuable if you use for the predictions of future growth modeling. I recommend this, and I'm checking whether there is any question from the chat I think no. So thank you again, and we can skip to the next presentation, which will be conducted by Ahmet Batuhan Polat. If he's ready, he can share.
Yeah, I'm ready.
Yeah, he can share his presentation. The title is Rapid Float Mapping with Sentinel-1 SAR Images and a case study of Maritsa River.
Can you see it?
You have 8 minutes. Yeah, we can see.
Okay.
Thank you so much. Nice.
Hello to everyone. I'm Ahmet Batuhan Polat. I'm currently master's student at the Yıldız Technical University and working as a research assistant at the Çanakkale 18 Mart University, Department of Geomatics Engineering. The title of the work I will present today is the Rapid Fluid Mapping with Sentinel-1 SAR Images, a case study of Maritsa River. These are my contents of the presentation. As we all know, the floods are natural disaster that occurs every year in many different regions of the world. Flood is one of the most common destructive natural disasters on Earth, causing loss of property and life. It's important to detect flood areas as soon as possible due to occurred flood disaster and provide aid to the damaged areas. Remote sensing and satellite images are a common method for analyzing flood areas resulting from disaster, as they are cost-effective and provide real-time monitoring. The aim of this study, which SAR images are used, is to examine the backscatter values and present them visually with the threshold value in order to quickly flood mapping as the result of the flood disaster. As a study area, the Maritsa River Basin in the west of Turkey has been chosen. The reason for being chosen as a study area is to affected by floods almost every year. When the rainfalls increase and causes to the floods, especially in the autumn and winter months, it's an important problem for Greece and Turkey. The location of the Maritsa River on map is shown in the figure 3, and figure 4 shows an image of the river taken from the drone. As we know, the optical and radar satellites are used in the remote sensing for ground surface analysis. These satellites are also used for analyzing the flood disaster, but optical satellites do not always get a perfect image during a disaster. As you know, the weather conditions and clouds that occur during the event may create some restrictions for optical images. However, the radar images are not affected by any weather conditions. For this reason, it's useful in flood disasters. Also, a smooth water surface can be easily detected in the radar image. This is because the high scattering on a flat surface doesn't ensure that the returning microwave energy cannot be detected by the receiver. The SAR images used for the study were obtained from the Sentinel-1A radar satellites provided free of charge by the European Space Agency. Sentinel-1 allows the viewing SAR images in 4 different C-band imaging modes with single or double polarization. The acquisition dates of satellite images are 30 October 2020 and 3 February 2021. The first date is pre-event image and second is the during event image. Since the raw SAR images are not suitable for the direct use, they must go some number of pre-processing steps. In this study, first the orbit information of the SAR images were updated. Later, the thermal noise in the image were removed. After that, the noise occurring in the image borders were removed. Then with the calibration of the performed after this process, the pixel values were directly associated with the radar backscatter. The speckle filter was applied to remove the speckles that negatively affect the image. Finally, the terrain correction of the image was made and the corrected surface model was obtained. After the pre-process steps, the backscatter values were filtered by using the threshold values. Finally, the flood areas were obtained with filtered backscatter values for before and after the disaster. In the figure 5, you can see that the images obtained before and after the disaster in the study area with different polarization and after the pre-processing steps. When we look at the results and compare the tables, it's seen that the lowest backscatter value is obtained from the image taken with the vertical horizontal polarization during the event with minus 27.647 backscatter value. And according to the average backscatter values, the lowest backscatter value was obtained from the vertical horizontal polarization during the event. Also, the histogram graphs of the backscatter values for all images are given in figure 6. Finally, in the vertical horizontal polarized image where the lowest backscatter values were obtained, the threshold value was applied to the backscatter values, and the fluid areas were visualized on the Google Earth for pre and after the event. Sorry for that. In the figure 7, we can easily see that the area shown with threshold value application clearly shows that the water areas after the event. In this study, one of the fastest methods for detecting fluid areas after sudden floods with SAR images were examined, and the results obtained were analyzed. Optical satellites images are not always available during a flood disaster. The reason for is the meteorological conditions that occurred during the event. Another advantage of the using radar images for fluid analysis is that due to the flood perception of water surfaces, a smooth back reflection can not be obtained, and the backscatter values are perceived as a very low in the water surface or flat surface in the radar. So this advantage has been demonstrated in the study. As a result of the study, it was seen that the image accuracy polarization that most distinctly detected the fluid areas was vertical horizontal. The worst result was obtained from the image taken with the vertical polarization. According to the results obtained in the study, SAR images provide the necessary facilities for the detection and analysis of the areas affected in a rapidly happening natural disasters such as flood. In this way, threshold values can be determined from histogram graphs with the help of the backscatter values in SAR images used for rapid fluid mapping, and areas can be displayed on the map. Thank you for listening. That's all I can say.
Thank you for the presentation, Mr. Polat. Actually, I consider that this study is ready for publication because it's a really crucial river through which a lot of flood problems exist between among three countries. So if I will recommend your paper to be in a peer review process for our journals. Thank you so much for your presentation. And I didn't receive any questions from the audience, so we can directly skip to the next one. From Thailand, I think. Nitaya Katekaev.
Okay, I'm here.
I hope I pronounced your name correctly.
Yes.
Her topic is assessment of spatiotemporal distribution of anchovy catches based on vessel monitoring system and MODIS satellite data in the Gulf of Thailand. You can share the presentation with us on full screen. You have 8 minutes. Thank you so much.
Okay. Hello, everyone. My name is Nitaya Ketkaew. Now I am studying in SCGI Master Program in Burpa University and Wuhan University. This topic for present today is assessment of spatial temporal distribution of anchovy catch based on vessel monitoring system and MODIS satellite data in the Gulf of Thailand. Overview for concept to this study. Phytoplankton and seaweed is primary producer in marine ecosystem. It gets their energy from the sun ray using the green pigment known as chlorophyll. It absorbs light energy used in production of food, and anchovy is more pelagic fish. It first level carnivorous consumer. Therefore, if it found a lot of phytoplankton, it will also find a lot of small pelagic fish living in the area. We cannot see fish in the water, but we have satellite sensor technology to see how much chlorophyll concentrate is the surface temperature to predict where the fish will live. And we also have another important piece of information, namely of fishing position of anchovy fishing vessel from the vessel monitoring system. We therefore analyze their two parts together for future in this study. Introduction about VMS. The VMS monitoring system works same as GPS. Two functions work together to know where the vessel is from the signal transmission with the navigation satellite. The whereabouts the vessel will then be reported, sending the signal via communication satellite. The person who will receive the information is the owner and administrative staff. Introduction about anchovy fishing gear. Anchovy fishing gear is only licensed gear. As anchovy are small fish, fishing net have to be small. The fishing vessel reaches to its catch anchovy in the Gulf of Thailand consists of three types, include anchovy falling net, anchovy surrounding net, and anchovy leaf net. Importance of anchovy. Anchovy play an important role in marine ecosystem, not only as an herbivore for plankton, but also as a target fish for local commercial fishery. The high catch statistic and great value market. It's necessary to have an education about the spatial temporal distribution of anchovy and related environmental factors for sustainable use anchovy in the future. Gulf of Thailand. Gulf of Thailand is a semi-enclosed sea located in the Southeast Asia and connect to South China Sea. This area is quite shallow by average deep about 40 meters and deepest is 80 meters near the center of Gulf. This area is important for fishery and aquaculture for many countries. Gulf of Thailand is influenced by monsoon system. The northern monsoon occurs from October to January, with being cold air in this area. For non-monsoon, during February to April, wind become westward from South China Sea and change direction to northward in the northern part. This time is summer season. Will the southwest monsoon occur from May to September and bring high precipitation to this area? This time is rainy season. Method and objective. The data in dry season use data in February to March and wet season in July to August 2019 are specific and used into analysis. Fishing data use data from vessel monitoring system checked with the fishing logbook by comparing the location from the GPS system, noted by fishermen, and from VMS. This was used to check the accuracy of anchor fishing point. The weight of anchovy obtained from the fishing logbook were used for calculation, and model satellite data includes sea surface temperature and sea surface chlorophyll A of level T 4 km were used to analyze. Only modeled cloud-free images were taken into consideration. And GAM is a non-parametric regression technique, not restricted by linear relationship, but flexible regret rate of the statistic distribution of the data. The main objective of this study, 1, to compare the fishing position in two different seasons, dry season and wet season, and 2, to use generalized additive model for determine the fish distribution in relationship to environmental conditions. Data used by three types of data: VMS data from Department of Fishery in Thailand, and sea surface temperature and sea surface chlorophyll A used for model satellite data. Result about fishing position relative with average chlorophyll A. Chlorophyll A was high in the upper Gulf of Thailand near the river mouth located in the northern coast and near the western coast of the central Gulf in dry season. Chlorophyll A in wet season was higher in the spread wider across the upper Gulf of Thailand. However, the value in western coast of the central Gulf in this season was low compared to in dry season. Result about fishing position relate with average sea surface temperature. Sea surface temperature in dry season was lower than in wet season, and long coastline around the Gulf was found to be higher than that in outer region in both seasons. Analyzed by GAM relative effect of model prediction, chlorophyll A and sea surface temperature in dry season and wet season indicate the 65% confidence interval. The relative density of data point is shown by the dark plot on the x-axis. In dry season, its frequency of fishing operation of chlorophyll A was less than 0.2 to 0.6 milligram per cubic meter, and high catch rate on 0.2 to 0.4 milligram per cubic meter, and the frequency of fishing operate in sea surface temperature was 28.5 to 29.5 degrees Celsius, and high catch rate was 29.0 to 29.5 degrees Celsius. And in the wet season, high fishing frequency had the chlorophyll value in the range of 0.2 to 0.6 milligram per cubic meter, and high catch rate during 0.2 to 0.4 milligram per cubic meter, and sea surface temperature in the range of 29.5 to 31.0 degrees Celsius, and high catch rate in the range of 29.5 to 30.0 degrees Celsius. And conclusion 1, anchovy distribution and catch were intact in low coastal area, and the catch volume in dry season was longer than in the wet season. And 2, GAM analysis suggest that the higher fishing frequency by relative to 0.1 to 0.8 milligram per cubic meter, and chlorophyll A 28.8 and to 29.5 degrees Celsius of sea surface temperature in dry season. In wet season, high fishing frequency occur when chlorophyll A is 0.2 to 0.6 milligram per cubic meter, and sea surface temperature is 29.5 to 31.0 degrees Celsius. Thank you for your attention.
Thank you so much for the presentation. I haven't received any questions from the audience, and I really liked your presentation. I would like to congratulate you. And we are looking forward to your participation again for the following events, by the way. Thank you. The next presenter
Okay, thank you.
From Spain, Ahlem Nezrek, the use of photogrammetric techniques for virtual modeling of historical heritage, an application in Santa Barbara Bridge, Almeria, Spain. So if she's ready, she can share the screen with us. Thank you. You have 8 minutes, by the way. Please stick it to the time because we have some measures, lockdown measures, and we shouldn't be late to homes. Thank you. Miss, we cannot hear your voice. It's not coming, actually. It's not working. Your microphone is not working. there is no signal swinging in the icon of microphone. Maybe your computer didn't accept, didn't. Now slightly not so good. Haven't you checked before the presentation? No. Let's do this. I will skip to the other presenter, and by the time you can arrange the settings of your microphone, okay? I am skipping to the other. So Mohammed Yusuf Öztürk, if you're ready, you can start now. We can change the order by the time she is preparing her microphone.
Okay, can you hear me?
Yes, we can hear you. You can drag to share your screen. All right, you have 8 minutes and good luck. Thank you.
Okay, thank you. Hi everyone, I am Mohammed Yusuf Öztürk, working as a research assistant in the field of remote sensing at Geotechnical University. I will present the study named Investigation of the Effects of Vegetation Index derived from UAV-based RGB imagery on land cover classification accuracy. The presentation consists of 5 main sections. We will start the presentation with a brief introduction, study area, and dataset with methodology. We'll follow it. Finally, I will give the results and conclusion, then I will complete the presentation. Gathering accurate and reliable land use and land cover information about the Earth's surface is a prerequisite for the success of a wide range of applications carried out at local, regional, and global scales. Recent developments in the field of UAV technologies and imaging sensor systems have led to a renewed interest in extracting required information about Earth surface objects from a high spatial resolution UAV images. Image classification is one of the effective ways for extracting meaningful information from the remote sensing imagery, and the main outputs of the process is thematic maps depict land cover types of a given study area, widely used as a main data source for land-related studies. Supervised pixel-based image classification, that one of the popular classification techniques to produce land cover maps. Pixel-based image classification is generally based on the assignment of the image pixel into predefined land cover classes using their digital numbers. The RGB UAV-based platform is an alternative and low-cost aerial platform technology, ensuring the capturing surface image at very high spatial and temporal resolution. Although the RGB cameras are able to provide high spatial information about surface, their spectral resolutions are limited for distinguishing spectrally similar pixels. In order to overcome this limitation, the auxiliary data such as vegetation index, texture features, or physical components have been widely used in image classification process. The main purpose of this study is to analyze the effect of the use of RGB-based vegetation index on the classification accuracy. For this purpose, 3 popular vegetation index preferred in many studies, namely Greenleaf Index, GLI, Red, Green, Blue Vegetation Index, RGBVI, and Triangular Greenness Index, TGI, were utilized in this study. Classification results were evaluated using overall accuracy, kappa coefficient, and F-score measurements. The study area covers the northeastern part of Gebze Technical University, located in Gebze district of Kocaeli province. Within the boundaries of the study area, there are faculty buildings, other man-made structures, green vegetations, and bare soils, as shown right side figure. Study area consists of 6 main land cover classes. The first is concrete class, including gray stone floor, wood, gray and white roofs. Second is forest class, including deciduous trees, coniferous trees, and grass. The third is parkour class, including bicycle route, basketball, and tennis court. And other classes are shadow, soil, and tile. In this study, UAV image were acquired on 24 September 2020 by Phantom Pro drone equipped with a 20 megapixel RGB camera. Pix4D mapper application was preferred for flight planning. The image collected from 80-meter flight altitude with 80% forward overlap and 70% side overlap. Microsoft Photoscan software was used to process the obtained image, and as a result, an 8-bit orthomosaic with a spatial resolution of 5 centimeter was produced. Trevant UAV image was used as a main data source, and all vegetation index were calculated from this image. 5 data sets were created using RGB bands and vegetation index for evaluate classification results. Datasets 1 includes only RGB band. Dataset 2 consists of RGB bands and GLI. Dataset 3 consists of RGB bands and RGBI. Dataset 4 consists of RGB bands and TGI index, and dataset 5 corresponds to a combination of RGB bands and all vegetation index considered in the study. All datasets were classified with random forest classifier, and finally thematic maps were produced. It should be noted that image classification process was performed in our software, and best parameters of random forest classifier were found applying grid search method. As could be seen from the figure, the use of datasets consists of vegetation index with UAV image increased the overall accuracy in all cases compared to the use of dataset 1. In other words, the highest overall accuracy value was estimated as 91.2% from dataset 5. Whereas the lowest overall accuracy was observed as 90% from dataset 1. On the other hand, the overall accuracy value calculated from dataset 4 was very close to the overall accuracy value of dataset 5. Additionally, dataset 2 and dataset 3 were produced similar results with respect to estimated overall accuracy. This result shows that the TGI index performed more effectively in improving the classification results compared to other index. According to results of F-score measurements, concrete, forest, and parkour were classified with over 91% accuracy. On the other hand, when the highest F-score values were estimated for parkour class, the worst F-score values calculated for soil class. The reason why F-score value of the soil class is lowest may be that various substances that are mixed into the soil and have similar spectral properties with other land cover classes can be easily distinguished in the image obtained with the UAV. The best class level accuracies of each class produced by the use of dataset 4 and dataset 5. Furthermore, the Addition of the aforementioned vegetation index to RGB ones increased the class-based accuracy of concrete and tile roof about to 3%. Thematic maps produced by the random forest classifier for each dataset. According to visual analysis results, similar thematic maps were produced for each dataset, as you can see. It's seen that the soil class is mixed with the shadow and concrete class. This visual result is consistent with the F-score values of the soil class. In addition, it's seen that the noise generated in concrete class is reduced in the thematic map produced using RGB image and all vegetation index compared to other thematic maps. The following conclusion can be drawn from classification results. Accuracy of the thematic maps produced using vegetation index and RGB bands were increased about 1% compared to the thematic maps accuracy derived from the classification of visible spectral bands only. This could be probably a result of the increase in spectral information by means of vegetation in this usage. On the other hand, the estimated overall accuracy value in the dataset using the TGI index outperformed the results calculated from dataset using other index. Moreover, this is only 0.1% difference in overall accuracy between dataset 4 and dataset 5. According to these results, it can be said that TGI is the most effective index in the classifying 3-band UAV image for considered dataset used in study. Different vegetation index can be evaluated with various robust classifiers, for example, SPM, like GBM, CCF, and HTC, in order to better analyze the effect of vegetation index on the classification of the UAV image. Thank you for your attention.
Thank you so much for your presentation. The following one will be Ms. Ahlem Nezrek, and if her microphone is ready, she can start now. Can you give a sample of voice? Again, no. Again, no. Is there anybody else who can hear her except me? For instance, Mr. Öster, can you hear her? Or this is my problem only?
No, sorry.
Can you hear Ms. Ahlem Nezrek, for instance?
Do you hear me?
Can you hear her?
Do you hear me? No.
There is a very, very, very low voice. There is something, but it is not hearable.
No, okay.
No sense. Let's do something like this. I will schedule you for tomorrow because in these circumstances you are not able to present with this microphone, and I would like to enable you to present your work. We will try again for the tomorrow session because your current microphone does not give us a chance to hear you. All right, so I apologize for this. Or let us give you another chance for try your microphone, and I will give an additional presentation before you. Let's give 10 minutes more. You can try with, or you can log off from the Zoom, and I will add you again as a panelist. Let's try again like this, okay? I am accepting now Eyüp Mohammedi. He has been waiting for a long time, but he was scheduled in the morning session. Can you hear us, Mr. Mohammedi?
Do you hear me now?
Mr. Mohammedi, can you hear us? Shall we hear your voice, please, Mr. Mohammedi? Mr. Mohammedi, can you open up your microphone, please?
Can you hear me?
Yes, we can hear now. Please, you have 8 minutes. Please go.
That's okay. That's okay. Hello, everybody. Honestly, it is my pleasure to be here in the second Intercontinental Geoinformation Days, known as IGD, Mersin in Turkey. However, before presenting our paper, I would like to thank the honor board organizing and the executive committee from Turkey or other part of the world for holding and handling this conference. So our topic is a medium-sized rainfall-induced landslide detection using L and C-band SAR images, a comparative study in agricultural lands. The presenter is Ayub Mohammedi, who is a postdoctoral researcher at Department of Remote Sensing and GIS, University of Tabriz, Iran. My co-authors are as below. Associate Prof. Sir Dr. Khalil Walizadeh Kamran, Assist Prof. Sir Dr. Sadra Karimzadeh, and Professor Dr. Masashi Matsuoka. Okay. The introduction. Let me start first with background of the study. Landslide is one of the geohazards in terms of damages that will occur. Landslides are almost happen everywhere on the earth. In Gilan province, landslide cause many damages to agricultural lands every year. Remote sensing technology presents the best methods for detecting post-disaster damages, including landslides. Synthetic aperture radar SAR data have widely been used for landslide monitoring. In SAR technique, interferometry, synthetic aperture radar is a valuable technique for landslide inventory and have been used worldwide by the researchers. The accurate identifying of landslide is very essential for this disaster response management. Pixel-based RGB band combination method detect landslide directly from the satellite data. The current study can be significant because it compares either ascending and or descending directions of satellite C-band data with ALOS2 pulsar 2 L-band for detecting an occur landslide in agricultural land. The main objective of this study was to compare the suitability of Sentinel-1 and ALOS2 pulsar 2 on landslide detection in agricultural land of a part of Gilan province, Iran, which I will show you in the next slide, the study area. You can see the study area is located in northern part of Iran in Gilan province. In the vegetated areas, here is agricultural lands of the study area. We only choose this study area in vegetated area because we want to examine whether C-band in either directions, ascending and descending, can detect occur landslide like L-band synthetic aperture radar or not. Satellite data for this study is as this table. Sentinel-1 both ascending and descending directions, orbit or known as also orbit type. Data acquired for the ascending is 1st April 2020 and the second one is 13 April 2020. Product is SLC, which is used normally for deformation studies. And descending orbit type is the date is 27 March 2020 and 20 April 2020. For ALOS2 pulsar 2, we used only ascending direction, which I'll show the result by then. That could detect the occur landslide, small size occur landslide in the study area. The date is for 29 January 2020 and 22 May 2020. Research methodology. Firstly, I have to say that the orange color boxes are just for Sentinel-1 products, and the blue ones is common for either data. To update some information like speed and so on, we have to use applying orbit file and to update some in order to stack the pairs of both satellite data for 2 different dates, we have to use co-registration operator. Enhanced spectral diversity is a operator that normally ESD correct the shift along tracks. That is why by applying these operator, we can have a more precise co-register image. But we have to mention that the burst must be over 2 for this operator. For 1 burst cannot be operated. However, interferon formation can extract for us both coherence and interferon formation that many data and information can be extracted from both coherence and interferon. Top slippers. Normally, Sentinel-1 data have some bursts among this data and should be debursted to retrieve some information between the bursts. Topography phase removal operator can be used for removing the phase topographic on satellite data. Before unwrapping this data with SNAFU software, for fasten the satellite data, phase filtering and multi-linking should be done.
Mr. Mohammed, please stick it to the time, okay? Because it's getting a bit longer, all right?
Yes.
Just emphasize the key points, all right? Thank you.
Okay. Phase displacement, phase displacement can be used for converting from radian, a unit from radian to centimeter. And at the end, the data must be georeferenced using geometric terrain correction. The final step was belong to assessing the results using Google Earth and GPS. Result and discussion. This is a result for ALOS to Pulsar 2 that using band combination method of RG, pre-event for R and post-event for G in green color. So every deformed areas in this combination method can be seen in green color, which is very clear from both magnified and the main result. But as you see from both descending and ascending result using Sentinel-1 with that is a C-band with only 5.7 centimeter, and this is happened because of penetration capability. L-band with 24 centimeter wavelengths can penetrate more into vegetation coverages, while this cannot be happen for Sentinel-2 that is C-band with only 5.7 centimeter. That is why both descending and ascending directions couldn't predict and detect the occur landslide as ALOS to Pulsar 2. Finally, for every study, mainly in remote sensing and GIS, we have to evaluate our results. Here, we have used both Google Earth and GPS for evaluate our result. Using a handheld GPS, the occur landslide were seen on the field, and using Google Earth, as you know, in optic images like Google Earth, and in vegetated areas, when a landslide occur, it left bare land, so clearly can be seen from optic satellite image also. reference, and any question?
Actually, we haven't received any question on YouTube and on Zoom, so thank you so much for your contribution.
Thank you.
So if Ms. Ahlem Nezrek resolved the microphone problem, she can start now, or otherwise we will do an extra small session in the lunchtime tomorrow. The decision is yours, both for Ms. Atakaka and for Ahlem Nezrek. I can schedule a small session in the lunchtime tomorrow.
Okay.
Because your microphone doesn't work properly, so by tomorrow, please resolve this problem. So I'm about to close the session, and the two ladies, Atta Kaka and Ahlem Nezrek, please be on time with proper internet, proper equipment, everything should go well. During the lunchtime, we will get together again. For the other presenters, I would like to remind all that in the face-to-face events, there is nothing like this. We need to be punctual, we need to be on time in our presentations, because I'm not talking to any person, I'm talking to general. We cannot change the order of the event. We cannot change the sequence. So everything should be punctual, everything should be in order. In the face-to-face events, there is nothing like this, but for virtual conferences, we can make some, let's say, some excuses. But this is, in academic life, there is nothing like this. You need to present at the time that the technical program says. So tomorrow, please be on time for your sessions, because we cannot rearrange all the schedule. We are totally mixed up. So thank you for your participation for today's sessions. We have swiped up 35 presentations today, and it has been a tough day for us, but it has been very valuable, efficient, and effective one. So thank you so much for your participation, and I'm closing today. See you again tomorrow at 9 o'clock in Turkish local time in the morning. Thank you so much.